So today, that is the topic of the tutorial, building complex web apps in Jupyter with Jupyter Widgets. And I will let Matt and Juan introduce themselves also.
Hello, my name is Matt Craig. I am a faculty member at a state university in Minnesota. I teach physics and astronomy. Got introduced to Python about 11 or 12 years ago and haven't looked back. So as widgets started to come out, I started to use them in my research work with students, and as that work has gone on, the needs I have for those apps have gotten more and more complex, which is part of my motivation for helping to work on this.
Hi there. My name is Juan Cabanela. I am also a professor at the same small state university in Minnesota. I did teach physics and astronomy until our administration apparently decided that I was better in computer science, which I have not figured out yet. But in any case, I got turned on to Python right around the same time Matt did, and I've been using Python for well over a decade now. I've been developing web apps mostly for educational purposes when I developed stuff for use in the classroom, and did that using widgets. So there we are.
Can I just mention Martin? The fourth presenter we have listed, Martin Breddels, wasn't able to be at the conference, but he helped us develop a couple of the notebooks that we'll do at the end about the Solera framework, and is the author of the Solera framework. So he sends his regrets, but looks forward to feedback. If you don't have a Post-it yet, can you raise your hand? If you came in late and need a Post-it. Okay, I'll get those out to folks.
All right. So I'll leave the URL up for a few more seconds. While that's up, I'll talk about the prerequisite knowledge. For this tutorial, we are hoping that you're at least somewhat familiar with Jupyter Widgets. You may not have used them recently. You may need a little review, and we'll go over some of that. But we do build a lot on top of the more basic concepts, and so we'll move past that content fairly quickly. And so don't forget to poll. We made some very recent changes, so your first step is to go ahead and poll, and there's also a line in there to update your environment in case the environment has updated since the last time that you polled. Okay, so we wanted to get to know you and get you to know each other. That'll take a second.
Can you go back to the update environment command?
Sure. Okay. Lots of updates. Very fun. All right. So there's an instruction there, but it should be already loaded into our environment again, so we can ignore that. So we wanted to get to know you and get you to know each other. So we want you to turn to your neighbor and ask if you have worked with Jupyter Notebooks, what domain are you from, and what you hope to get out of this tutorial. So go ahead and turn behind you maybe, or to your side. Say hello. All right, go ahead and wrap up your conversations. All right, I'm glad that everyone enjoyed getting to know each other. Hopefully we can do that a little more over break. Okay, thank you for your attention. So, the expectations for this tutorial, you may interrupt with questions at any time. We might have somebody come and give you individual help if you need that. And we're going to have stickies to indicate when you're done with an exercise. So why don't we go ahead and start and make sure that you use your stickies to show us that you are ready to go and that you've pulled the tutorial and the changes.
If you have done a Git pull since arriving here.
Okay, and I see a few people without stickies, so if you're not prepared, go ahead and we'll send some help. Okay, we'll get started. So we'll go over what we're going to learn today. We're going to start, we've started installing our environment, and we're going to do a little review, both of Jupyter Lab and SciPy widgets. We might mention the benefits of Jupyter and building in Jupyter Lab, and then we'll move on to reviewing NBDev. You may or may not have heard of NBDev. It's a tool for building simple, for building packages and also building scripts inside of a notebook. We'll go over the Pydantic and SciPy Auto UI packages, as well as Solara, to start making more complex applications, and then we'll get into the deployment stage where we talk about various options for deploying notebooks for others to see. Okay, so that concludes the beginning of the welcome notebook. So go ahead and click on, and this is your file browser if it's hidden, and go ahead and click on 01A, getting started. So we'll try to briefly review notebooks, specifically Jupyter Labs and widgets. So we will go ahead and we'll briefly say the benefits of notebooks are that we can program iteratively. People talk about Jupyter notebooks and literate programming, but we're gonna take that to a little more extreme of an extent by using the NBDev package. This tutorial is a little unique in the sense that we will actually be building an end product along the way in our notebooks, not just in scripts that make a product. We'll inadvertently build scripts that become our final product through our notebook. But we'll talk about that more. And we love Jupyter because they're already used by scientists and data scientists. So when you're collaborating, there's room to collaborate with people who already know these tools. So there's like a social barrier that's not just a technical one that we're overcoming. And then we like Jupyter because it's ideal for visual outputs and widgets. There's tons of tutorials here that have great visualizations, and there's a rich ecosystem for that. So we'll get started with Jupyter Lab. As we said, we have our file browser over here on the left. And of course, we always want to use Shift-Enter to go ahead and run our code cells. Maybe. Right, so this is a SciPy widget. It's a slider. And one little trick we'll learn is a right click and we can go ahead and create new view for cell output, and we can see the widget standalone now. And you'll see if you move the widget in the standalone viewer, it's got the same model underneath, and they're both updating. So we have bidirectional communication with our widgets. To review our widgets, we'll go ahead and run this cell, which is a handy little tool where we can see all of the SciPy widgets. So our SciPy widgets are most basic Jupyter widget package, and we can see we have a lot options for a lot of them, which of course are in documentation, but we have this handy tool. So the exercise here is to pick a widget and to go ahead and enter it here. So find a widget and create it. Maybe I'll make a toggle button. And to display that button, I don't have to actually write display, but if I wanted to, this is actually what's going on under the hood. I'm using the system to display the widget. So there's many packages other than SciPy widgets. We're going to review several of them in this tutorial. Specifically, SciPy data grid for displaying data frames, and SciPy matplotlib for interactive plot windows. So hopefully,
You lied on that last part, sorry.
Hmm?
You lied about that last part. We're not going to do the interactive plot.
oh, cool. Yeah. All right. All right. So that concludes getting started. And we'll head into our workflow. Great. So we will be creating an app exploring land ocean temperature data that comes from NASA. And the goal of our notebook is to quickly review the code that that's going to end up in our dashboard, but in a state that would be more like a workflow before it ends up as a dashboard, right? So we're not just creating a dashboard from scratch. The idea is that we have maybe some code to start with, and we're going to update it. So we will run through that. So we'll upload a data file. We're going to have this graph that's got a whole bunch of sporadic data, and we'll use some various smoothing algorithms to update our graph. And we'll take a range of the data, so we don't have to go from the start and end of the data. We can take particular years, and then we'll create a new data file. So that's our basic workflow. So go ahead and load the required libraries. And load the data from the file. This is just a CSV that's sitting in our directory. And you can see that we have years here and temperature data, and that we're displaying that with, we're displaying our pandas data frame. So we'll next plot the raw data with matplotlib. And we'll add a column for filtered data. So we'll use a couple filters. This isn't my area of expertise, so we're not going to go over the science of these filters. However, we will have a few parameters that we will give our user a little more control over later. So we'll have, specifically, we'll have window size and polynomial order. And you can see that we've updated our data. We have new columns, and then when we plot that, we now have several lines here, the original data, but also our smooth data. Okay. Now we will select certain data. So here we've said 1920 to 1980, and you can see in our pandas data frame that that is the start and stop of our column data. And now we can plot that specific selection of data and output it to a CSV file. Okay, so this is just to get familiar and to get a sense of where we're going with this, and the sense that this is a real workflow that we're building from. So that's the end of the workflow notebook, and go ahead and open up 02A NBDev. Okay. This is the part where I get to get all excited about NBDev. I love this little tool. Hopefully I'll communicate it in such a way that its import for me makes sense to everyone else. So the goal for this particular notebook is to better understand how we can use NBDev so we can develop in a notebook but actually get a Python package out of it, so we can have a very clean notebook output later when we're done with our dashboard, right? Our dashboard won't have all this code in it. Our notebook will be rather clean. It'll just call the thing, but the development notebooks will be filled with all of our trials and errors, all of our thought processes and how we got there, our notes on how we designed it. But in the end, we can get a nice clean notebook that has this lovely dashboard and not all this messy stuff and deploys really nicely. Okay, so steps that we will take in this notebook. Yeah, let's talk about NBDev a little more. So it is a notebook-driven development platform. You don't have to use it with just widget development, but it's really handy for that because widget development is very notebook-based. So it's very handy to be able to make small changes in your widgets and not have to reload all your Python files. I mean, VS Code has things to make these things nicer when you're developing, but it's nice to do them from a notebook, and NBDev makes that easier. There's a note here. When I say NBDev in this tutorial, I mean something actually much smaller than the whole tool of NBDev. NBDev, you can use it to write any kind of Python package. It comes with a lot of niceties, and it's meant for developing entire packages and release cycles and all this. Whereas we are just going to use a few critical functions that are from the modular NBDev toolkit. And so it takes a standalone notebook and turns it into a Python script. The nice part about it is we can tell it with our exports which code cells that we're going to end up exporting. So our default export directive is going to go at the top and tell it what module or what file we're outputting to. And the export directive is going to go at any code cell and tell us that that code cell is indeed going to get exported into our Python script that's going to come out at the end of the day. And then at the bottom, there's just a nicety where it's a notebook export function, which is the function that turns our notebook into the script. You can do this from the command line, but there's a function that you can use to call that from the bottom of your Python notebook instead, where it's very convenient because you're done developing. So I'll stop there. Does anyone have any questions about that? No?
Anybody's running into installation issues or bugs?
Right. So hopefully it is clear why exporting cells is convenient for us and how being able to leave all our iterative thinking in our notebook is beneficial and separate from the nice clean code that we'll make.
Kind of a incidental question, but does NBDev require you to have SciPy widgets installed, or does it just work no matter what?
Yeah, thank you. The question was, does NBDev require SciPy widgets? And the answer is no. NBDev is for any kind of Python, and it just happens to be nice for using it with Python widgets. Thank you for your question.
Quick question.
Yeah.
Did you explain the difference between default export and export? Are we supposed to know what that is yet?
Sure. Are we?
We have time. Okay, that's coming.
Next step. Thank you. Right. Okay, so the goal specifically for this notebook is we are going to create a Python module called dashboard, right? So that's where we're headed, and we'll start in this very notebook. This very notebook will be the beginning of our dashboard module. So to answer your question, the default export defines the target file for the export, right? So if I want to export to a particular file or a particular module, the default export tells me that. So you only have one default export per notebook, and we put it at the top of our notebook generally. So yeah, so we're going to create a few line and cell magics that we'll use throughout the rest of the tutorial. And we want these magic functions to be accessible anywhere in our code. So it makes sense to put these functions in the init file. And so we're going to use the default export to do this. So this is our first exercise. We want to go ahead and add the default export directive to place exported cells in init.py and go ahead and give that a try. Okay. So we have our default export, and it's going to be to the init file. And that's without the py. So when you do your exports, they don't have the .py extension. We'll skip over that. Right, so now about marking a cell for export. We use the export directive. They must be the first line of the cell, and the cell can only contain imports or other Python commands, but not both. So we want to make sure our imports are separate from the rest of our code. So go ahead and add the missing export statement to this line. Cool. All right. So okay, so we don't require putting anything else here, just export. And now this particular cell will end up in init.py later down the line. I see that. Cool, we'll see. Third time will be a charm. Maybe we'll unplug it and replug it if that happens again. Okay, so now we need to define the exception cell magic. We'll just show what this is, show and not tell. So if you execute this cell, we can see here that typically when we get an exception, and sometimes we want to do an exception so you can see what the anticipated result is. You know, we want to force an error and then maybe fix it. But that can be really annoying when we intend to do that, but we don't. We want to be able to restart and run all our cells because maybe, I don't know, we've executed things out of order or something. This allows us to continue execution without getting hung up if we restart and run all. And you can see what that looks like if we don't do that. Okay, and then we also have the answer magic, which is just another tool for this tutorial. The answer magic helps you load in the actual answer for any cell. So to use the answer magic, you uncomment the answer, and there will already be a file there. You run it, and you can see that the answer is auto-populated for you. So this is a way to give it a go, and if it doesn't work.
When it puts that answer in there for you, though, just be aware it does not execute it. So you will have to do a shift enter again if you end up having to resort to using the answer. Does that make sense?
Yeah, so for the microphone, the answer, you do have to re-execute the cell, right? So if I execute it once, I get the code I'm supposed to have. If I execute it again, I actually execute that code. So don't forget to execute it twice. Okay, and finally, we will take the exported cells and export them to our init file using this notebook. This is the name of the notebook. This is the name of the module. And we can expect, does anyone have an idea of what file, where that file will be when we create it? Yeah, in a folder called init.py will be in a folder called dashboard. Great. Make sure, here's a caveat, make sure you do Command S or whatever your Jupyter's save command is before running the export there. Okay.
Can I ask a question?
Yeah.
So I tried executing that cell with the answer in it, and it recommented that line. Is that normal?
Yes, yeah. So then if you change it or something, you can do it again.
Okay.
So it's there as a record of
Oh, okay.
where you got the answer. Mm-hmm.
Zach, can you explain that just one more time? Is that basically you're pulling code in from somewhere else? Like this is the answer to a problem?
Yes.
Is that what's happening?
Yeah, so this is just a tutorial nicety that we've written. So we have answers stored like in this file, right? So we created code that goes in dashboard init, but there's also a key dashboard init, and we pull in the answer from that for you in case you get hung up and have trouble.
And that's an IPython cell magic, nothing to do with it.
Right, that's actually, we just created that cell magic, yeah, from scratch in this notebook. Yeah, thanks for your question. Okay. Okay, so now we want to be able to actually use the dashboard module that you just created, which, by the way, was not in the tutorial directory before you just made it. So go ahead and try to import the code that you just exported. Right, and the trick here is that with init files, you don't actually have to import them. You just import the module, and the code in the init file is imported. Great. All right, so now we will go ahead and use the load line magic to inspect the code that we just exported. Nope. Oh. Or I could have done, answer. Oi. There, that's it. Yeah. Yeah, so what we've just done is imported a really big file that's hard to see on our blown up screen, but we have imported init.py. So you can see that our current open notebook has been turned into the file that's shown in this cell. So there's some, these comments are what NBDev uses behind the scenes to know what came from where. Okay.
Sorry, can you go back up?
Yeah. To yeah, so I loaded dashboard in it here. And when I use a load magic, it pulls in the code from a file, right? The load command loads all of the text from dashboard init.py. And that's what's shown here. Any questions about that? Okay. Okay, so what's your question? Okay. All right, so that pretty much concludes this as well. Does anybody have any questions about NBDev and how it works? Okay. Yeah.
So, what's the order in which the these happens? Say I export some files and maybe I rerun the export for some other cell again, and where's the order?
I'm not sure.
So we have this export key in the top bar.
Mm-hmm.
Says that we want to go into the final file. What determines the order when we actually do the export? In which
Oh, yeah, so it's a linear, oh, as in all the files. It depends on your question. So, okay, so the question was what determines the order of what gets exported. So for a particular notebook, it'll be a linear order from top to bottom. Right, so it's not dependent on any of the execution order. When you programmatically export it at the bottom there, it's in linear order. Mm-hmm. Does that answer the question? Sure.
I had a bit of difficulty with the logic of this too. Just if you think of NB export as actually running on the command line almost, all it's doing is it's reading the notebook and then just pulling out the cells that you've marked. And doing a little bit of magic. There's some auto-generated things that go in there to make it a full module.
Okay. Yeah, that concludes this notebook. So make sure you save the notebook before and then if you wanted to be extra safe, you would save the notebook and redo the export statement.
I made a bad guess as to what I should call my default export, and so the rest of the notebook doesn't run properly. Could you go back up to that line where you do the default export? And I don't know if that's important. Do you want to help them individually?
Sure.
Yeah, I can.
Yeah. Mm-hmm.
Okay. So we're going to advance here while he's getting his individual help. I want to advance to discussing widgets. So let me pull this up. A show of hands here. How many people have been have used SciPy widgets before, or Jupyter Widgets? Okay, good. How many of you have done it in the last, say, 3 months? Okay, so what we're going to do here is we're going to be fairly quick because we have to develop everything that we did in that workflow before. We're going to develop with widgets. So we do have to go through it all, but we're going to be fairly quick. Okay? So now I'm going to go ahead and all that wonderful exception handling that was just developed and we built that dashboard, I'm going to go ahead and import that. So hopefully if everything worked for you, that import command, you will now have the exception handling that we need when we do some of the stuff down here so that we don't crash our notebook if we want to choose to rerun it. So basically what I want to go through here is the logic of widgets a little bit. We're going to create a additional module inside a dashboard or additional package, I guess you'd call it, called widgets. So I'm going to default export that. The final product that we're developing is going to look something like this. So we're going to take that workflow where we were selecting, yeah.
I'm seeing a few red boxes where we maybe
Oh,
for a couple minutes so we get everybody caught up with the dashboard.
okay. So we have a few red boxes that we want to address.
Yeah.
If you're getting some sort of error, put your sticky note on your computer. We'll spend a couple minutes getting it.
Yeah, and so the thing I've seen the most so far is that for the default export statement, there's no .py at the end. So check that first. The .py is implicit. Okay, and then I'll come around.
If that was your error, you fixed. If that was your error and you remove the .py, you can go back, save it, and then go back down to that cell that had the MB export and hit MB export, and it should create it properly. And then you can test it by seeing if import dashboard works. Okay. Is it? Okay. Let me. Oh, that's the examples. Let's do this. Let's do this. Okay, there you go. It loaded. That's the whole thing. Okay. Just shows. So, in any case, we're going to take that workflow that we discussed, looking at land sea temperature data, and come up with widgets that control the range of years and the specific smoothing algorithm. So rather than displaying two smoothing algorithms, we'll just put some sliders in that let us choose what smoothing algorithm we want specifically. It is going to end up looking something like this. So it'll display the data, it'll have a graph here, and controls. Okay? So as a reminder, anyone remember what the import statement is for Jupyter Widgets, aka SciPy widgets? Yeah. What do we do? Import. That's the typical one, right? So we can run that. I am exporting that cell because we will want our dashboard to have those imports already taken care of. Okay? So I mark that cell. Here I included, in case you wanted to look at the widgets again, it's the same demo box that lets you look at all the widgets. By the way, there's a great, Nicole put together this great page that has all of the many packages that use Jupyter Widgets, as well as like other widgets that are available. And I did link to the documentation there for Jupyter Widgets. Although this, honestly, if you click on any one of these, it takes you to documentation. Okay. So first thing we're going to do, again, our dashboard's going to need to load the data. So I'm going to export a cell that tells it to load the data. And I'm going to go ahead and just, here I'm going to look and make sure that I can load that data here as well, just to see what it looks like, the pandas data frame. I guess I should ask, have most people used pandas? Okay, good. So first widget that we're going to add is a integer range slider. This one is for the year. We're going to want to be able to select both a lower bound and an upper bound on the years that we want to display, and that's what int range slider does. So here we create the int range slider, and we can go ahead and display it here just so you can see it. And you'll see that we use the default values. So right now it's stuck at a range of 0 to 100, but it will let you set the two bounds. Okay? We are using a style argument here, this description width initial. It's a style argument that lets you basically make it so the whole text appears there. Otherwise, I think it chops off it says range of and doesn't display it. All right? Yes? Mm-hmm.
I missed that. I was
Okay.
busy typing it. Did you import it as widgets? Or
I imported, I think I said import as widgets, right?
Okay, I thought I heard somebody say okay, that's
Yeah.
oh, okay.
Okay. So do we got that line then? Okay. Yeah, everything else will require it to be called widgets. Okay? So we're back down here. So a range of 0 to 100 doesn't work for us because we want to get all the years. So one thing we can do is we can look at the range of years of our data. So I looked at the original data frame, years column, and I asked for the min and max, and there we are. So it ranges from 1880 to 2023. And we'd like to set the limits on our sliders. So what you can do is you can set each of the slider, that the one that we're calling here year range, has minimum and maximum attributes that we can set. So I want you to see if you can go ahead and set those attributes. So it'd be year, range, and I'll let you guys. if you're very rusty and you don't remember how to access the attributes, but otherwise you can just access the year range slider .max, and I'm setting it equal to the maximum value for my data, and similarly for min. And if we go up now, once you've done that, if we go up to that slider, you should see that now it is reflecting the full range of values. I guess it's set, so the actual slider values weren't set, but it set the range. So now it goes 1880 to 2023. Are people seeing that? Okay. So that.
I ran into a problem on the setting the maximum. If you set min before max, then it errors.
Oh, okay. If you set min before max, it errors.
Yeah, because the min value is greater than the max value.
Yeah. So, okay. Set max before minimum. Something to keep in mind. Yes?
I wonder if you went to set the maximum lower than the minimum,
Yeah, it would probably choke, yeah. So, all right. We can actually check what the value is. So if you pull that year range right now and ask for a value, you'll notice that it gives you 1880 and 2023. That's how it's going to represent. Since it's two values it's got to keep track of, the minimum and the maximum, it returns a tuple. Okay? So programmatically, we could try to also set that. So instead of having done the minimum and maximum individually, we could reset those ranges. Or sorry, not the minimum and maximum, pardon me. We have two values because we're representing a range. So we can programmatically set that to something like 1900 to 2000 by setting it equal to a tuple. And you can see now that it actually says 1900 to 2000 here on the slider. So I should do this so I'm going to keep this handy down here so we can see the changes. Okay. Alrighty. So the next thing we'd like to do is make this slider actually function. We want this slider to be able to control what data we're returning. So we're going to take the original data frame and we're going to create a copy of the data frame called selected data frame, and that's going to be a copy that has a smaller range of years. So it's just going to make a copy with just the selected years that we want. Okay? So the logic behind that is you would do something like this statement here. So you would do selected data frame is the original data frame, and in pandas, then you use within the brackets, you put your logic for selecting the essentially the rows that you want to keep. So we're going to keep only those where the year is greater than the from year, or you could call it the minimum year, and less than the maximum year. So the only difference is we got to replace these things with values from our slider. So we would take this logic, and how do we get the values from our slider? So I have this here, but I want to replace from year and to year. So the value is a tuple. How do we get the first value in a tuple? 0. So we can do year, if I can, year range value 0, and for the second value, year range value 1. And if I do that, I have now created a selected data frame that should be only covering the years 1900 to 2000. Let's actually see if that's the case by checking the actual data frame. And sure enough, there it is. It starts the year 1900 instead of 1880, and it ends in the year 2000. Okay? So we read that slider, information from the slider, and applied it. Okay? Now, it would be nice if we could modify this code so that every time you use the slider, it automatically updates the selected data frame. And to do that, we're going to have to use the fact that widgets are built on the traitlets library. Basically, these are, if you have an attribute that's actually created as a traitlet, then every time that you can set a Jupyter widget to observe that traitlet. And so basically, whenever that trait changes, you can have a function react to the change. So the key is, so I'm going to create a function here. It'll take one argument called change, and all I'm going to do is print change. So I'm going to print a change when that comes. So I just create this on-range change, print the change. And I'm going to take year range, our widget, and I'm going to use its observe method, and basically the observe method is going to call on range change, that function, anytime it observes a change in the value of year range. Does that logic make sense? So observe is sitting there watching the widget, and whenever it detects a change in the values of the widget, it's going to call the function on range change. Okay? So we set that connection. I'll get more into this in a bit. This is actually poor practice. I'll show you in a second a better way to do this. But we're going to do that. And now, let me do this. Now, our year range right now, the values are 1900 and 2000. That's what we set it to before. I'm going to programmatically change it to 1880 to 2002. And you will notice it suddenly dumped out a bunch of text. That is the change. That's the content of change. So change is a dictionary. And you'll notice in that dictionary, along with the name, there are two sort of key things. There is the old value, which is the value before we made the change, and the new value. So you can access now, in that we passed it change into that function. Well, that function could use the value of change, that dictionary, to do something. And so we can actually update now. So we're going to create a function here, which we'll eventually export, that says on range change. What I am going to do is I'm going to, and I am accessing the global selected data frame. I'm going to make it equal to the original data frame. And I'm going to say that the lower bound is now change new, the new element in that change dictionary. And I'm going to make it equal to the lower value. So if we look back up here, here's that change dictionary. I'm grabbing the new key, and I'm specifically grabbing this value, the first value there. I'm grabbing 1880, and I'm also going to grab and set as the upper limit change new 1. And if I do that, we can test if this works. So let me say on range change, I'm going to connect this new version of the handler function. And there's a note here. Technically, you don't have to say. So I mentioned earlier that this approach of just pointing that observe function at the function you're interested that's observing the change, just doing that is considered bad practice. It has to do with the fact that what you really want to do is you want to tell the observe method, in addition to telling it what function, you want to tell the name of the trait to watch. Normally that's value. So you want to observe the value attribute and see if that changes. If you don't set that, it'll observe all changes in your widget. And that can lead to some really odd things. Like, for example, you could have private attributes that you've set, and when those change, it would respond to that. So generally, it's a good idea, and it's almost always, you just want to observe the value. So what I've done here to change this is I'm saying year range, I'm going to observe and react to changes in the value. Okay, so the attribute I'm watching is value, and we'll trigger that. And I'm going to programmatically now set it to 1990 to 1993, and then print my data frame. And here's the interesting thing. I replaced that function on range change but it still ran the old one that printed. Okay, this is one of those idiosyncrasies of Python. Functions are immutable. So even though we created a new function with the same name, the old function was still sitting in memory and linked to the widget. So what we really would like to do is we're going to unobserve. So unobserve all basically disconnects all the functions that are currently linked to a given attribute. So we're going to do that. So we're going to unobserve all, and then I'm going to, we're going to have to, let's see, we use unobserve all. I'm going to check to see, oh, previous cell returned an exception, sort of a weird one. We're missing something in our observe call. What am I missing? What?
The function to observe.
Not the function to observe, the function that will response, observe is sort of watching, so we have to include the function that's going to be informed when we observe a change. Does that make sense? Yeah, I just trying to be clear about my language. So it'll be on range change, and then we also want to pass it the actual attribute of the widget that we're going to be observing, and that's going to be value. And so if I do that, that should work. So in fact, I think I just did what this exercise was down here, which was to fix that year range. So let's fix that because that's the cell that we want to actually export. So we have this observe here, and now, remember, we disconnected all the previous functions. We've reconnected to our new version of onRange change, the second one we created. Now there should only be one function connected. So now, if I change the range, there shouldn't be any printing of that change dictionary, but it should show us the new pandas data frame, and that's what happened.
What's the use case where you want to observe something other than that?
Honestly, I don't know off the top of my, I mean, I suppose you could have, I mean, I could imagine, for example, let's say you create something where you have your own private attribute that you're hiding from someone, and you want to change that only in certain situations and then respond to that. So I guess it's the flexibility of being able to respond to not just the value changing, if that makes any sense. So the value comes straight from the widget, but you could be storing inside it some other private attribute. Okay?
I don't want to slow things down too much, but in that code where you declared a global, I'm not really understanding why that was there.
Okay.
And if it's not important,
It's not super important. It has to do with the fact that selected df was defined outside of the function, and if I want to change the data frame that's outside of the function from within the function without passing it as an argument, this was a quick and dirty way to do it. If you were into my introductory programming class, I'd have to slap my own hand for doing that little trick. But yeah, it was quick and dirty. And, sorry? Yeah, I like that. Okay, so, all right. So I've shown you a little bit about how to link widgets. Now, the other thing I want to talk about is output widgets. So output widgets are really nice because you basically, anything you can put in a Jupyter cell, you can put in an output widget. And so I'm going to create an output widget here. So it's going to be called selected data frame view, which might give you a hint that this is where I want to put the selected data frame to show it as a widget. And if I do that right now, though, it's empty. So you don't really see much because I just created an output that has nothing in it. It's pretty boring. It says here, so we'll go ahead and right click. This only works if you're running this inside a Jupyter lab, and we'll create a new view here. Close. Okay. So I'm going to create a new view down here so that I have the output view sitting down here. Otherwise, I'll have to keep scrolling back up to see if I change the output. But now what I'm going to do is, one nice thing is that this output widget actually supports context handlers. So we can use that with statement. If you've ever used context handlers for reading in files, it works here as well. So I'm going to clear the output, and then I'm going to display. Now I'm going to display the original data frame first, just to have something in there. So I fired it up, and you can see that the original data frame has now appeared in that output view. It's also in the one right above here as well. Okay? So, voila, there it is. Now, our selected data frame view now displays that we have that output is now displaying all the data. Now what I want to do is change this up a little bit. So I'm going to create a function that will update that output widget. And so what it will do is it will clear the output in the widget. Wait equals true is an option. So for the output widget, calling clear output clears the output. If you say wait equals true, it will wait until there's a change before clearing it. In other words, it will not clear it and then sit there blank. It will wait until it's been informed that there's new material to go in there, and then it will clear it and put the new content in. So we do that, and then with that selected data frame view, I'm now going to throw in, I'm going to display the selected data frame. So instead of the original, which covers the full range of data, I'm going to do the selected one, which I think had, at last count, had only 4 years in it, 1990 to 1993. So let's do that. And right now, we call this, let's see, we call the function. Okay. Now what I'm going to want to do is set it up so that whenever we observe a change in the year range, we will update the output selected data frame with a value, or with the value. So we'll use the values and update that. So here's the interesting thing. Right now, we already have, remember, one function that's looking at that year range. So observe, the widget observes a change in the value of year range and passed it on to that on range change, and that made an adjustment that creates selected data frame and changes the year range for selected data frame. I'm actually now attaching a second function, so we can have more than one function that's triggered, and in this case, this second function says, oh, and once you're, once that selected, if you've made that change, go ahead and display this as well. So display the selected data frame when it changes. So we have two functions run. So I'm going to create a year range here, a year range slider, so we have it. And here's what I'm going to do. So down here, watch carefully. If I take the bottom slider and start changing its values, that output should change. Do you guys see that? So I have two functions being triggered by changes in that widget. The first one creates a selected data frame that's chopped down. The second one displays the updated selected data frame. Okay? So our data frame is now reflecting the range of values, which is kind of neat. So now we have an auto, we just set it, and the data frame can be displayed if we want to. Now, this is a pet peeve of mine. Pandas data frames, there's one problem if you would discover if you were using this and displaying it in the output, which is Pandas data frames, when they display in Jupyter, don't always display the same length. So it will grow. So let's say it's only 3 rows. You'll see all 3 rows. Once you get past, I want to say it's like 15 rows, it starts putting in ... in the middle and shows you the tail and the head of the thing. So the problem is that if you use this as a display element, the widget is changing size, and it makes all your elements that are around it possibly move around, which is really annoying. Now you can play with other things to handle that, but there is actually a nicer approach, which is to use SciPy data grid. It's a widget for displaying data frames. So if we import SciPy data grid, and we import specifically the data grid widget, and I'm going to create, so instead of an output for this, I'm going to use this data frame instead, this data grid, and here's the nice thing about it. So let me close this up here. So here's the data grid. It actually has some nice built-in functionality. You can sort the data to view it, but it will always, you'll notice how it scrolls. It will always essentially occupy the same amount of space, or you can set it to occupy the same amount of space. So it's a nice way of displaying the data where it doesn't move, the widget doesn't have to like flex to accommodate the whole data frame. Yes?
This is going back to your observe function, right? You have two different functions observing the year range.
Yes.
One changes the data frame, one displays it.
Right.
Is there a difference or a benefit or a drawback to instead having one function that watches the year range and one watches the data frame, like chaining years?
You can't watch the data frame because it's not a widget. Widget, okay, just to be clear, so the attributes of a widget are traitlets, and that's what gives you the ability to observe changes in them, if that makes any sense.
So it's not like reactive variables.
It's not reactive all over. It's just to be clear, it's just that. Okay? Okay. So I'm going to modify, or I'm going to create a new handler function which we'll use that will just output that selected data frame using the data grid instead. And we'll export that as well. So this is just putting together the pieces that we have here. So if I do this now, I should be able to see that year range adjusted. Wait, did I forget to do something here? Just a second. Oh, I think I forgot to output this to the screen. So let's see here. Update selected data grid. Selected data grid is up there. Let's see if this updates selected data grid when I do this. Yes, it did. So sorry about that. It's a little confusing, but the slider's affecting the data grid that's being displayed above. Okay? Again, that works because SciPy data grid is actually a widget. So it can essentially receive changes to it as well. If that had been if I'd been using a pandas data frame and displaying it, the problem is I would have had to update the output and throw another copy of the data frame into it. Like I'd have to essentially keep resending it. This is more reactive. Okay. So, is that making sense so far? So we've played around with a couple features here, trying to get the communication between the sliders and the data frame display. Now, last thing want to talk about is we're going to have to create a couple other sliders because the other thing that we want to do is we want to be able to smooth that data. So the year-to-year variations in temperature can be quite dramatic, and you'd like to see smooth trends over time. So we are going to, rather than plotting two different smooth curves, we just want to be able to have the model is flexible enough that as long as we can adjust how many, like over what window size we're smoothing. So the algorithm, the way it works is, the smoothing algorithm is it fits a polynomial with an order that you select, but you also tell it what window size to smooth over. So it averages over, like if you set the window size to 10 years, it'll be looking at 10 years of data and fitting that with a polynomial as it moves along. So it's smoothing over essentially a 10-year scale. So we're going to want to be able to adjust a window size in a polynomial order. So what I have here is, just as an example, we apply that smoothing algorithm to the temperature column and create a new temperature column in our original data frame that I'm just going to call smoothed data. And if I do that and display the original data frame, you'll see now it's added smoothed data there. So that's a smooth version of our temperature data. We did that before when we did in the workflow. I think the column had a different name, but we did that before. We created a column with the smooth data. Okay? So we have these two variables that we want to be able to control with widgets. We're going to want to create a window size. Now, window size is a single value, so we can control it with a single integer slider. And here's the window size. I set the value to 20, and I gave it a minimum of 2 and a max of 100. And you'll see we can accommodate that. Polynomial order, we're going to create another widget called polyorder. This is a bounded integer widget. And it's essentially a single cell here that just lets you adjust up and down. Now, currently the minimum is set to 1 and the maximum is set to 3, and the initial value is set to 3. And the maximum was set to 10 and the initial value is set to 3. If you're fitting polynomials greater than order 10, you're dealing with much more complex models than I as an astronomer ever dealt with. What we want to do now is use those two widgets to control the smoothing algorithm. So what we want to do is on window change, we're going to look at the original DF and the selected DF. And again, we're accessing here as a global. To clarify, I'm doing that because I want to be changing the original data frame and from within the function. So we're going to go here, and basically what I want you to do is we want to modify the function in the next cell so it takes care of, and I listed two things. So we want to update the original data frame with a new smooth data column, and we want to use the window size and polynomial degree values from the widgets. So we want to access the values that are in these widgets. Then I want to create a column, in the original data frame of smooth data, and then I can use the data grid to display the selected data frame. So on window size change, we want to do all these things. So I'll give you guys a few minutes to see if you can fiddle around with this and get it to work. And if it works, you should be able to observe the window size widget and run. You can test it by running these cells down here. Okay. You have to finish 2B before we do 2C. Okay, well, we can check on it in a second, okay? So again, so what we want to do is, the first thing we're going to want to do is we want to update on window size change. So here's the thing. This thing's going to take this change. We're passing the change. Remember, the change is going to be the old and new values of window size. So what we're going to do is we're going to replace window size here with change new, because that's the new value of the window size. Polyorder is another widget. And being a widget, to get its value, we have to access its value attributes. So we're going to do polyorder.value. Okay, so does that make sense why one of them I replaced it with the word change, where the change dictionary, and the other one I access the value of the widget? You don't want to access window size dot value, because that won't properly be using the change that you pass to it. And actually, I know that I've had situations where if I accidentally make the mistake of using the value of the attribute while I'm observing the change, I get inconsistent results. So I always use the change. Well, we'll use change new here. Other than that, I think at this point, then this should work. Once I do this, let's see. Let's see if there was anything else in the answer that I forgot. But we can load the answer here. Yep, that was it. So I think that was it. We'll execute that cell. And now let's actually see if this works. So I'm now going to set up window size to do two things. It's going to observe the window size variable, and if it changes, if value changes, it's going to call on window size change and let it know. On window size change will change the selected data frame, what part of the data frame we're looking at, and then down here, we're also going to observe, and we're going to observe that value and inform update selected data grid, which updates the data grid itself. So if this all works, let's display the data grid, let's display the window size. And right now the data grid, here's the funny thing, selected data grid, because I haven't run this yet, doesn't know that there's a third column. The moment I make I change this window size, let's do this. Boom. It should. There it goes. It computed that column, and now selected data grid, the selected data frame. So we changed the original data frame, and then we selected a range of years from it. So the key here is that this function on window size change creates or updates the smoothed data column, and then creates a copy for only the year range we're interested in, and copies it over to selected data frame. Okay? So that's the logic that's going on behind there. And now let's deal with changing the polynomial order. So for the polynomial order, fairly quickly, this is the same logic as we had for on window size change, except for on poly order size change. I'm going to want to smooth the data, but I want to use the updated poly order value and the window size. So since it's poly order that we're interested in the change of, or that we're observing the change of, we'll do change new here for that. And window size is the slider we're not messing with here, so we'll just get its value. Yes?
Does the change new always access the value attribute?
It accesses the value attribute, the updated value attribute. So if, for example, you have a situation where you need to know the old value as well, you can access that. So change gives you, there was this entire dictionary of properties that came with change. Way up here, let me see here. It's way up here. There we go. So this is the entire dictionary that comes with it. It actually has information about style and everything. You can access hypothetically anything in that dictionary. Almost always, since you're usually interested in just what's the new value or the updated value, you go change new. If it was a tuple, you might need to do change new and then grab a portion of it. Depends on what you're changing. Okay. Okay, so we're back down here at polyorder. I went ahead and modified this function here so that window size, we're just checking its value, and I replaced polyorder, that argument in the filter function, with change new, the new value of polyorder. So if we do that, and then, did we execute? I think I lost my location here. Okay. It did execute that cell. No, it did not. Okay, we go here. We execute here. Now polyorder observe. So polyorder, I now attach to that slider polyorder. We observe for changes in that, and it will call on polyorder change when it detects a change in polyorder. And then it will also call update selected data grid. So it will, because changing the polynomial order can also result in a new smooth data column, or does result in a new smooth data column, we have to call the display of that. So we do this, we do the polyorder. I should have probably displayed the data grid. I have the feeling I'm going to pay the price here. Let's see here. Okay. I'm going to add a column. I'm just going to add the selected data grid here if it's working. So right now there's 4 years selected there. I'm going to change this. I don't know if we can see if there's changes. So the first number is 0.394. Let's change the polynomial order. 0.3. Oh, this is not promising. Oh, it's because my year range is so small. You can't fit a high order polynomial with only a few points.
Where you added the observes,
Mm-hmm. Yes?
the second one's window size.
The second one is window size. Oh. That's funny. Good catch. That's a typo in my code. I'm assuming it's an error on in your notebooks as well?
I
Yep.
tried changing it, it's still not updated for me. So
Well, let's see. It should be polyorder. Okay. I'm guessing now I've got it really confused because I've now recreated the function, the observes a few times. So let's do an unobserve all and see if we can fix this. So that clears out the previous observes. This adds these observes. Let me adjust the year range so I have more data.
you may need to unobserve window size
You think I may need to unobserve window size?
too, only because you haven't observed before.
Oh,
You know what I'm saying?
yeah, that one, okay, that won't affect the demo I'm doing here, but yeah. I'm glad I didn't export those cells, let's call it that way. But I think polyorder 2, yeah, I think it is not. It's not updating. Well, it was inevitable that there would be a problem. Murphy's Law. Okay. Trying to see if there's a quick fix to this. What? What's in my output? Ooh. Decimal is invalid keyword for round. Uh-oh, this is not good. Yeah, I may have to restart and run all. Let's see here. Let's clear that up. Okay. We'll try to catch up to where we were before. Okay, year range is now 1900. Okay. We got the data grid. We observe the selected data frame, update the data grid, set the range. We have these functions here, window size and poly order. Okay, there's a selected data grid, there's a selected window size. If we adjust that, that changes that. Okay, now we go to poly order.
So in the round method, I think the keyword is decimals, not decimal.
That would probably be it. Let's see here. Well, this one worked fine, I think. Or is it decimals or decimal? It's plural? Okay. Matt, are you keeping track of these changes by any chance? Thank you. Okay, since let me delete that cell and just see. Now this one also, that was window size before, it should have been poly order. Okay. Now we do this. And there we go. Poly order works. Yes?
I'm just curious that if you tell it to observe a function and then you change that function definition, do you have to unobserve and reobserve?
You would definitely, okay, so if you change the function definition, remember functions are immutable, which means that when you change the definition, what you're really doing is creating a completely new object in memory. But it'll still have the old one linked.
Okay, so you have to.
Yeah, you have to, that was why I attempted to unobserve all when I thought I had screwed that up. Okay? Okay, are we good so far now? We're up through poly order. Okay, so now here's an interesting problem. Try setting the window size value to 3 and the poly order to 5. Yeah, it's hard to fit a polynomial fifth order with 3 data points. So this leads to an interesting problem, and the slider doesn't automatically, the sliders have to be able to know that there are these limits in there. So what we're going to do is every time we change the window size, we're going to have to update poly order to know that there's a new maximum that's allowed. So if the window size goes down, poly order will get shoved down in value below a certain value. Now poly order, I think it was limited to 10, but let's say the window size goes down to 3. Well, what's the highest order polynomial you can fit with 3 points? Any math majors? Any physicists? So you're always stuck, your polynomial order is always going to have to be your window size minus 1 as the maximum value. So we got to modify this function. So we're going to modify on window size change. And this, you'll notice that we're finally going to export on window size change. We modify this so that it responds and it changes the maximum value of the poly order here. So now we don't want it to be that if the window size goes to 20, we don't want it to just keep increasing it. So we're going to want to set this to be the maximum value. So let's see, we'd want poly order max, and we're going to set that to the minimum of 10 or the current window size, the new window size value minus 1. Or pardon me, when the window size, it's got to be, yeah. There we go. I think that should do it. So the polynomial order, we're now capping to prevent that error. So here I do unobserve all, because as you pointed out, I just redefined this function. So we unobserve all, we reconnect those functions. We check window size and polynomial order, and now watch this. If I change the window size, or let's see. Unfortunately, yeah, by the way, the polynomial order didn't get updated until I changed the window size, which is why it still had invalid values. But now I can do this, and let me max out the polynomial order to 10, and watch what happens as I drive down the window size. At some point here, when I get below, you'll notice now the polynomial is being forced down in value. Okay? If I slide this back up, we can go back up again. It did catch on. Once I slid it past 11, it allowed it to go up to 10 again. So it adjusted the polynomial order to behave properly. We're going to export some default values. We're going to set the window size to 10 and the polynomial order to 1. A polynomial order to 1 is basically straight line fit. So that's I think what's referred to as a running average in that case. It's just averaging over a window of 10 values. All right. Last thing we have to do, matplotlib. This is the part where I lied on the earlier slide and said I was going to give you the widgety version of matplotlib. I'm not. I used the default or the normal version of matplotlib, which will come and bite me later, so don't you worry. This will bite me later. But here's the plotting commands that we used earlier. So we created some labels, title, plots, plotted multiple sets of data, and we plotted the raw data and the smooth data, and then a legend, and we showed it. Here, what we want to do is we want to turn that set of commands into a handler function that accepts a change parameter. So whenever we basically, let's see here, we basically want to take these plots, or these plotting commands, and we want to change it so it uses the proper, the column name that we were using here. So instead of sgcol, it should be smooth call, or smoothed, was it smooth temperature or smooth data? This will bite data. Smooth data. But then we want to put all this into a function that's going to be triggered. Okay? So let me first see if this works. Nope, what did I do wrong? Oh, not subset. What was it? Selected df. So there's our data now, the plot of it. Okay? And so the plot shows up inline. We want to be able to put it into an output widget. So here, I'm looking at the time. Okay. We're going to load it into an output widget, and I'm going to be a little fast here and suggest to you just grab the answer from the answer key here. And we're going to create the blank output widget. And then once we've created the blank output widget, we basically just need to add a content handler for plot views. So we're basically going to set it up so that whenever plot view changes, with plot view, we just throw all the plotting commands at it. So all those plotting commands from the line above, we basically just throw them in. So anytime, however we call output plot, whatever widget we observe a change in that we used and call output plot, it's going to update the plot. So let's do this, and I'll display plot view, which is hopefully an output widget. It doesn't have anything in it yet. Now it does, because we have called it. And now here's the thing. All three of those sliders that we created, all three of the widgets, could potentially change the plot. So for every one of them, if they change, we rethrow the plot at the screen. And so we do that. We set up that observe. We're going to go ahead and export a default range of years. And I've put in sliders here. Let's see here. What do I do? And now, so I've got those sliders there so you can control it more closely. And you'll notice that right now it's plotting from 1900 to the year 2000. And if I change the slider here to more modern times, it's now restricted to 1972 to 2000. But it is responsive. The graph is responsive. Okay? So, along the way, what I've been doing is, there was a bit of experimentation here, but what we did is the cells that contain the stuff that we wanted to use, the various output widgets that we wanted to create, the observe functions and so forth, all got tagged with an export. So now I have to save this file so we make sure that we have the bug fixes in there. And this might explain, we'll see if that explains what Voci was doing later. But now I can export this, and you should see in this dashboard directory, there is now a widgets.py, which contains all of the various functions that we created, as well as all the commands that are necessary for displaying the widgets and monitoring the changes in the widgets and so forth. So basically what we figured out here is the logic that controls the communication between the widgets and the display. And I think probably it would be a good time for a break now. What do you think?
I think we've got a snack break in 20 minutes.
Oh, so let's go through. Yeah, let's go through. So let's finish the layout of widgets. So we still haven't produced the dashboard because we've got to lay out all the widgets. So hopefully if widgets worked and you got a widgets that got exported here, you should now be able to go to the layout discussion, or the layout, which is O2C_layout, that dashboard. We're again going to load up the exception handling. So here what we're going to focus on is laying out the widgets that we just produced. So we have essentially 5 widgets that we have to get talking to one another. We have the 3 control widgets. We have the data grid that displays the selected data frame, and we have the graph. We have them talking to each other. All those elements are there, but we want it to be displayed as a dashboard. So we basically have to deal with the layout. So we're going to export this, and we're going to call the module main. So it's going to create a dashboard main. Now the first thing that we want to do here is, and this is partly a check to see if everything worked from before, we want to be able to import these functions. So we have these functions that we want to import, all of those functions. We want to import them from our dashboard widgets. So we should be able to say from dashboard widgets import, and then, because I don't like violating PEP, there we go. See, Matt, this is one of the reasons I like VS Code more. It auto aligns. But there we are. So all those functions that we have now exported from our last notebook are available to us right here. So we should be able to do that. We import them. Okay, and let me just check and see that, yep, selected data grid. And remember, we set up some initial values and we had it read in the data, so it is there and available for us to use. Okay? So we can do the plot view and show that, and we can do the year range, show that, and these are even responsive right now. You can see that year range is interacting with the plot. So are people getting this? Is this working for people right now? Okay, good. So now we just got to deal with the layout. We did deal with widget styling. I'll just mention we did a kind of utilitarian widget styling before, where what we did is we just adjusted the description width so that you could read the entire description of a slider. There are way more controls available for those of you who have played with these. You can control color, fonts, all sorts of things for all your widgets. We're not going to discuss that, but we are going to discuss widget, the layout attribute, which also has access essentially to the cascading style sheet properties. So let me redisplay the year range styler, or this year range widget, and I want to make it wider. So I'm going to change its layout and the width value to 500 pixels. And you'll see now, it now takes up 500 pixels on the screen. You can similarly display the other widgets that we have, polyorder, and I'm going to set it to be 140 widgets wide, or 140 pixels wide. Oh, I know I need the drink. Just a second. I'm starting to stutter over my words. Okay. So we can also adjust the selected data grid, and this is one of the nice things. We're going to adjust its height and its width. And this is the thing I was getting at. It puts in a nice scroll bar for it. That's part of the widget's behavior. And the nice thing is that we don't have to worry about our widget changing size when we change the data that we select. So that'll be a fixed size. So for container widgets, you can have widgets that hold other widgets. This is the typical way that we do layout. One of the widgets that's available is the accordion widget. So we can put the selected data inside of an accordion widget. You'll notice that there's not a lot going on here because I haven't given it a child widget. So when you have a container widget, it contains other widgets inside it. I'm guessing most of you remember HBox and VBox. Do these sound vaguely familiar? So you lay out widgets, and so what you have to do is set the children of it. Now we only have one child we want to put in the selected data because I want to be able to make the selected data appear and disappear. So I put it in an accordion, but we're going to get a problem when I do this. So if I try to do this and I set the children of the accordion to be that selected data grid, it chokes. Anyone want to get, can anyone determine from that error message what the problem is? You need a comma, it's a tuple. So the problem is, the way parentheses are handled in Python, you need a comma to tell it that that is a tuple instead of just a single value in parentheses. So we're going to fix that down here and add the comma, and that will now tell it that it is a tuple, and it should take it just fine. And now, if I go up here, you'll notice that now I got this little triangle here on the accordion widget, and if I click on it, there's our selected data. If I click again, it goes away. So it is now populated. Now by default, when it opens, it is closed. So in fact, if you ask selected index, it'll say right now, because I left it closed, it'll say none. In other words, it's not displaying anything. How do you think we would open that? Programmatically. What could I do if I wanted it to be displayed open? Yeah, and there's only one child in there, so if I set the selected index to 0, it opened up. And in fact, now if I check what the value is of that selected index, it should say 0 instead of none. There we go. Okay. Next thing we're going to do real quick, the final dashboard had some descriptive text because a person doesn't know what these sliders do unless you tell them. So we're going to use the ability, there's an HTML widget that just dumps, you take HTML and just displays it. So we're going to create an intro text here that just describes what the tool is going to do, it's curve smoothing, and a text describing the sources of the data. And we're just going to store those as 2 constants. And then you can use, I'm going to create a layout is just a widget, but it also controls the layout of other things. So I'm going to set a layout that has a maximum width of 500. And I'm going to use the HTML widgets, pass it those values for the text, and pass it the layout object here. And now if I display it, there's my intro text, nice HTML. And the description of the data. All right? So now we're going to arrange all those widgets in H boxes, horizontal boxes, and V boxes, vertical boxes. The layout, again, I have a layout here, so I'm going to set all of the curve parameters, the things that control the curve fitting. I'm going to create a curve parameter layout, and all I'm doing here is I'm basically telling it how I want it laid out in terms of the actual attributes, the 500 pixels width and so forth. And then I'm just going to say, create an H box, make the children the window size and the poly order, and make the layout this layout that I just described. And if we do that, now I have in a single container both of those sliders next to each other. So I have this slider and the poly order slider next to each other. We also have the year range, which I made 500 pixels wide, which conveniently is the width I made the other thing, the width that I made this curve parameters widgets. So those are two together. So I can use a vertical box now, or I'm going to ask you guys, use a vertical box. You're going to call it the description and control box, like that. And I want you to basically make a V box that contains both the year range and this curve parameter widgets. So if you're remembering VBoxes, I just set my children to be, I put the curve parameters on top of I put the first item in that tuple, the year range the second item, and if I do that and everything works, now I got both of those controls next to each other all assembled together. The building, you know, you can adjust the layout margins a bit. So I made a tweak here. I added a little padding here, but only to the outside of this box. So when I did this command here for to adjust the layout of this, I put margin, but it only put margin outside the whole thing. Any idea how I would put padding to each of the widgets that's inside? Yeah, you're going to have to do like a loop or something and access all the children. Given the time constraints that we working under, I'm going to load the answer here. But this was the solution I had here. So I just, for a child that's in that children, I went ahead and tweaked the margin. Okay. Now I want to add a vertical box that holds both the table and the plot visualizations for the selected data. So we have a data box, or we're going to create a data box here. And that's going to be a VBox widget that contains both our selected data accordion. So that's the data frame and plot view. And what was my glitch? Widgets. Plural. So many typos. Did we rename this at some point in this process? Probably. I think that's the same typo I had earlier, but we'll grab it from there and make sure. I think you're right. Yes. There we go. So it execute, and now, so now I have this display that shows both this data accordion and the plot on top of each other, and now we can use a horizontal box, put those together, and we have the entire set. Now, unfortunately, because I've adjusted the size here to make it larger, the display is using large text, it's kind of crumpled up. I'm hoping that on your guys' displays it's a little more clean. I just realized that I forgot the descriptive text. So I should go back here. And this should also include the descriptive text that we had here. So we want intro text and data source text. Intro text, data source text. And now those appear there, and if we go back down here, there we go, yeah. So now it's including the description, the controls, and the plot all together. And we created this all in a single widget. There's some layout margin tweaking that we do here. And at this point, if everything worked, we've created a main, and that main is our entire dashboard. So we can export that. And before I go to the very last thing I want to cover here, I'm going to point out there were some challenges that we had here. First of all, we had multiple handler functions in some cases dealing with stuff. That logic can get very confusing very quickly. I'm sure you didn't notice it because my delivery was just flawless. But in addition to that, you needed to have the handler functions dealing with validation of the inputs. Your inputs might have the poly order window size issue. You needed to check that the inputs were, you needed to be explicit in your handler functions to deal with that validation issue. And then we had to have, we had to lay out this thing with H boxes and V boxes to get all the control widgets all put together. That gets really confusing, especially if you have a lot of controls. So part of the reason we went through this, along with reminding you about widgets and creating what we needed, was to show you it's kind of a pain. It'd be nice if some of these problems could be dealt with more cleanly, which is what Matt's going to talk about. That said, if you open O2D dashboard, that's to show you here's your final product. This is just to show that if everything worked, now I'm importing it from the key, but right now I trust myself enough to think that this worked. So I'm going to remove key from there and import it from the dashboard that I created on the fly here. And if everything worked, there's the dashboard being displayed, albeit, let me do this. Oh, I don't use Chrome regularly. What's the? There we go. There's what the dashboard should look like, albeit in tiny text right now. But the whole point is, you now have in one notebook a single command. Essentially, we imported it, and everything, all that logic that we developed in the other notebooks is squirreled away in our module. And we can just go main widget, and boom, we're done. Okay? So this is kind of the nice aspect of using NBDev, is that we went through and we exported only the bits and pieces we needed. We saved that, and we can just pull it up here. After this, after the break, Matt is going to give you a description of basically how to do this much more, as widgets get more complex, the logic is going to get a lot harder to sort of keep in your head. And so he's going to show you some of the other tools that you can use to make those much more complex widgets than this, or much more complex desktop dashboard apps, to make them much more tractable. All right. Stretch your legs.
I plan to be back at 3:50, so 10 minutes before 4. Is it okay if I switch windows? Okay.
Can you just slide the years and verify that they update the graph? Okay.
Yeah, yeah. 'Cause
For
it's
me,
got-
it's
nice
the
and
upper
fast.
range. If I try to do the upper range, it doesn't update the graph. Oh, but here it does. So it's a mistake. in my
I can
code.
take a look at your code.
It doesn't really matter, as
got
long
method
as
for
I
showing
know
you,
that
like, the visible
it's probably just a tiny
data.
observe.
So
Problem.
I was thinking it'd be nice to have to have it.
Yes.
You could load the answer, so you say your notebook and then load the answer number one, so there's a change that you catch.
Okay.
We're gonna have to fix that one glitch that,
Decimals is
Yeah.
the only problem, right? Okay.
and I'm gonna.
Oh, that one was a real pain in the ass.
Did you make like?
No, I haven't yet. Because I don't have my computer, right?
Okay, that's right. Okay, I'm gonna, because I'm wondering if that could have possibly been.
Yeah, if there's an error in one of those functions, then of course you're not going to see an update either, right?
I'm wondering if that business would be bad, the window size not getting caught. That got in there. Yep, it's in there. Damn it. Okay.
So,
Matt, are you okay with me pushing
heck yeah.
the bug fixes?
Yep. What? Oh, it's not grabbing the right kernel.
So poly order was one error. Was there another error that we had got into the notebooks?
Decimals, or did you already get that one?
Yes, thank you. I don't know how that got in there too, because I ran this. I ran the damn notebook like 3 times.
What's the block on your troubleshooting?
Sorry?
Are you troubleshooting?
Oh, I'm troubleshooting Dabari, which
And I'm fixing.
isn't working
the
for some
bugs that
people.
got caught during the thing so that we can push out a fix, so that the code will be.
Yeah, the one thing that I run into is that there were some definitions that were not in the, like widget wasn't fine. And then.
It should have been, so it may be a
question of, maybe a question that the unfortunate aspect of this is, of course, if the first notebook fails to produce the right,
Then it's a cascade.
it's a cascade. Yeah. So, give me a second.
No, no.
I just want to make sure I commit this change.
That's unfortunate.
2 minutes of freedom.
Mm.
20 years, but undergrad, I worked at some strong stuff. So yeah, that's actually mostly, yes, no, I do contribute to that, yes. We were looking at degrees in math lab or mathematics or something, do some KBO detection, some computation. Yeah. That was a long time ago. But yeah, just to compare how I think there wasn't any community libraries or software. Oh, it's so much easier to develop. When I was in grad school in the 90s, we had to write all of our own software. And now it's like, I look back on it and I go like, dear God, how did I get through writing my own Commodore fitting routines and things like that? I mean, it was like, and I know how it was because we used to look at the big red book that had all the code in it. But, anyway, it's been very good. I'm sorry, it was probably like, it felt like drinking from a fire hose. I know. But you're very affable and very. No, 24 years of teaching, or 25 years of teaching will do that. I'm just checking, I patched everything. I'm just curious if we'll see it's not. I don't think it's in place. Can I steal your kind bar?
Well, so I was gonna So the question was whether you should go ahead and pull again. I wouldn't right now, because if you pull right now, it's going to want to replace whatever you've already done. So the couple of things that we stumbled across in the first part of the tutorial, we've made those changes, and so later on I would go ahead and pull those in.
Okay.
So the rest of the notebooks are going to be flawless. And I'm just going to wait another minute or two. There's a couple of computers without people, so. So I'll resume with the main tutorial comment in just a moment, but I wanted to motivate it a little bit first by showing you an example. So Juan and I have been working on a package for doing stellar photometry, which is measuring the amount of light coming from stars in an image. And there's a bunch of settings you have to provide to do that. And so the complete set of widgets that we have to do all of those settings look like this. I've got different settings in different tabs. Some of these settings have optional things. We don't need to go through this in detail. The point is, it took us about an hour and a half, with some frustration along the way, to connect 4 or 5 widgets together. Right, there are probably 30 or 40 or 50 different check boxes and text boxes here. We didn't put this together by trying to write this by hand. And so what we're going to turn our attention to now is a different way of building more complex apps. And so if you could open the notebook 03A, Pydantic, it should look like this. We're going to spend the next 30 minutes or so talking about a package called Pydantic and how to use Pydantic, even though on the surface, Pydantic has nothing at all to do with widgets. The way we're going with this is that Pydantic provides a nice compact way to define a set of settings and that kind of thing. And there's a package which can turn a Pydantic, what's called a Pydantic model, into a widget without you having to write any extra code. So on the left, if you could click on the outline view, because in a moment I'm going to have us skip a couple sections. So before we do that, our goal here is to define a data selector class that represents the range of years that we want, the window size, and the polynomial order, and eventually contains within it all of the constraints that we want. So the window size should be limited to a range of 1 to 100. The polynomial order should be 10 or smaller, and should always be less than the window size. Do make sure that you import the dashboard, because we'll use the answer magic. And quick show of hands, how many of you have written a Python class before? Okay, most everybody. How many of you have used Python data classes? Few people. A data class, we've got some more content in the notebook that you can read about in some more detail, but a data class is essentially a compact way of defining a class in Python. And if you work through the section of the notebook that we're going to skip about data classes, in a data class, you decorate with a data class decorator, and you define attributes in your class by using type annotations. How many of you use type annotations in Python? It's more than expected. How many of you like using type annotations in Python? well, okay, the overlap between those two is about 100%, which I guess I should have expected. I don't use type annotations in Python, except in cases like Pydantic or data classes where it saves me a lot of effort. So on the left, if you could jump down to constructing a data selector class with Pydantic. Oh, yeah, so this, I don't know which version of Jupyter Lab added this, but now there's a button on the left that gives you an outline view. So the first code cell here is something we're used to. It's the default export that we'll use for NBDev. So in Pydantic, the way that you define a class is by subclassing from something called base model that Pydantic provides. And in a Pydantic class, let me blow this up. So we're going to define several classes here, successive drafts of this model that we're trying to build. And in the first version of it, I'm going to subclass from base model, and then to declare attributes in my class, I just list them in the class definition and give a type for them. In this case, I'm also providing default values, so pure polynomial order is an integer whose value is 1, unless you provide a different value. So already this is kind of good, right? We had these 3 separate things in the earlier example of this. Now they're bundled together. The nice thing that Pydantic, or one of the nice things that Pydantic does for you, is that it understands the types that you want. And so if you try to create a data selector model that's got a window size that's the word 3 instead of the number 3, you'll get an error. If you did the same thing with a plain Python class or with a Python data class, you wouldn't get any errors at all. Okay, so first exercise here is just for you to make an instance of this class that doesn't raise an error. I'm going to give you about 30 seconds to do that. If you're running into problems, don't forget you can put your Post-its up. So there's a bunch of different possible answers here. You just need to make sure that first thing's a tuple, and the next 2 items are integers. Pydantic is fairly forgiving, so if you put in a polynomial of 1.0, if it can convert that to an integer, it will. I'll just mention in passing that there's a few different ways that you can make a Pydantic model, and we'll come back to one of those in a little bit. But for now, I'm going to skip over the model validate section because it's not key to what we're going to do next. So far, Pydantic looks great, right? I can make something that understands data types. And so what do you think is going to happen when I run the cell? Is it going to run, or is it going to raise an error, do you think? So, okay, so we're expecting to get a validation error. So the expressions I'm seeing on some of your faces are priceless and are exactly how I felt the first time I saw this. Pydantic is fairly widely used, and in many cases it's used, or the items you're making are meant to be immutable so that you don't change them later. There is some cost if you have Pydantic check the types of values as you set them, and so if that's what you want to have happen, you have to opt into it. And so by adding when I create the class by adding validate assignment equals true, then when I try the same thing, I do get the validation error that we expected. And you can kind of see where this is going. We're going to be able, in a couple minutes, to express things like I want polynomial order to be between 1 and 10. We're going to be able to express that fairly compactly in Pydantic, and Pydantic is going to take care of letting the user know when something goes wrong. Questions up to this point? Okay, so turns out you can set year range to anything you want, and you won't get an error. If we look back at how we defined year range, it was a tuple, and we gave it an initial value of 1800 and 2000 because we knew what we wanted that to be. Pydantic's like, you wanted a tuple, you got a tuple. There's also a spelling error there, but the fix to this is to provide a little bit more information to Pydantic about what we want that tuple to be. And so in the next draft of this, the year range is not just a tuple, it's a tuple that has two things in it, and they both have to be integers. The square bracket notation here is something that comes from Python's type annotation system. We'll see some more examples of this a little bit later on. And so now, if I put that additional information in there, I can no longer set the year range to something nonsensical. Questions yet? Okay. So I mentioned a moment ago, we want to be able to impose constraints on some of the fields. So we want window size to go from 2 to 100. We want polynomial order to go from 1 to 10. And eventually, we want a relationship between those two things. Recent versions of Python provide a convenient way of adding this. There's two new pieces in here. I'm grabbing something from Python's typing module called annotated that lets you indicate that you want to provide additional information about the type of a variable. And I'm grabbing something called field from Pydantic, which lets you provide constraints, default values, a whole bunch of different things about individual fields that you're defining in your model. So a little bit of language thing in Pydantic. These are typically called fields rather than attributes, and so that's the word I will use going forward. And the class you're making is typically called a model. So the new thing I've added here is that on the window size, I'm annotating that it's an integer, and the constraint that I'm going to impose is that the window size be greater than or equal to 2. So no errors when I do that, and now let's test that. I should get an exception if I run this because I'm setting window size to 0, and sure enough, we get an exception. The other nice thing is Pydantic does a pretty good job of telling you what the problem is, right? So instead of reading the entire stack trace, you get a pretty clear indication of what the issue is. Okay, so we also wanted to have an upper limit on the window size, and field has the option to provide a upper limit also. So here I'm imposing the constraint that the window size be less than or equal to 100. If you look at the Pydantic documentation, there are a number of other options for constraints you can impose, like the length of a string or number of items in a list or that kind of thing. And it's very flexible in terms of letting you write additional, more complicated constraints if you need that. Okay, so as an exercise here, go ahead and modify this line where the polynomial order is defined so that it's got a limit that it has to be bigger than or equal to 1, less than or equal to 10. And I'll give you a couple minutes to do that, and then we'll check in. So if you're done with this, if you could slap your Post-it up on your computer so I have some sense of whether I should keep pausing or whether, okay, that's a lot of Post-its. So just like I did with window size, I want to annotate the type to give Pydantic a little more information about what I want. And in this case, I want it greater than or equal to 1, less than or equal to 10. I always forget that. Closing bracket. Wow. Third time's the charm. Okay, so now we've got those constraints imposed, but we have another constraint, right? We want to put a constraint that polynomial order always has to be less than window size. Another way that Pydantic lets you impose constraints is using something called a model validator. And let me get that imported. And so in this new version, first part is what we had above, so same fields we had before. The new bit is that I've added a method to the class called limit polynomial order. And I'm telling Pydantic that this is a model validator. So this is something that's meant to validate the model as a whole as opposed to individual fields. And mode equals after means that I want this validator to be run after Pydantic has already checked the type of the fields and any constraints that are on the fields. So if you try running this class and setting polynomial order equal to 15, the code will never, this model validator will never run, because you provide an invalid value for polynomial order. There is a before mode, which lets you run your validation before the field validation, and I think there's a wrap mode that lets you run before and after, so there's a lot of flexibility there. And what I'm doing in here is checking whether the polynomial order is bigger than the window size minus 1, and if it is, I raise a value error, and Pydantic will catch that value error, re-raise it as a validation error with the explanatory text I put in here. At the end of the validator, I need to return self. That's the way of telling Pydantic everything was good, keep on going. Okay, so try this out. So make an instance of data selector model draft 6. And once you've made it, try setting polynomial size and window size to an inconsistent set of values. So you want to make it first, and then try setting polynomial order to 5 or something, just to confirm that it breaks. So when you do this, you get a validation error, and the message that's passed is the one that you put into the class. So questions up to this point? Okay. I'm going to get up on a soapbox and for a couple seconds talk about other nice things about Pydantic. I hadn't used it before about a year ago, and to say I've fallen in love with it is probably an exaggeration, but it's one of my better friends. So a couple other things that Pydantic gets you is that you can easily get a representation of your model as a dictionary. You can dump that as JSON if you want. And once you've got the JSON text, you can write that to a file. We'll do that in a moment. Another way that you can create a Pydantic model is, instead of typing the Python code, is just to read in the JSON file. So here I'm dumping out the model JSON, and then I am creating one of these draft selector model 6s, whatever it is, from that JSON. And so if you have a bunch of settings like that you want to save on disk, which is the case with the photometry thing I showed you a little while ago, where we want to have a record once the student I'm working with is graduated and long gone, I want to know what settings did they use. So if you want to, you can write the JSON out. It should show up here. There it is. Read that back in, and you get your model back. If you don't want to write it as JSON, you could write it as YAML or something else and just handle the conversion to and from JSON. So the next thing took me a while to understand because I hadn't heard of JSON schema before I started reading about Pydantic. But in a nutshell, what JSON schema does is give you a description of what would constitute valid values for a particular set of JSON fields. And so Pydantic generates that for you from your model. And if you read this, it's not, I don't know that I'd really call this human readable, but right, it's not that bad, right? The year range is an array that has at least, most 2 items, at least 2 items. Those 2 items have to be integers, and you can see the constraints that we put in for the field values in here also. And this, it turns out, is key to the package we're going to look at in a moment that generates the user interface for you, because it can look at the JSON schema and say, oh, you want something that's an integer that goes from 2 to 100. Well, good news, there's an int range slider, or int slider rather, from SciPy widgets. I'll make one for you. I wanted to mention it is also possible to insert additional information here. Let me switch back to this for a second. So in this user interface example, there's a name of a field and a short description with it, and the way that those end up getting inserted into the widget is by a little bit indirect. So you create a dictionary that has whatever things you want to put in there, and then in field, you include that dictionary. And one of the things that can be in there is description. If description is there, that'll be used to decorate the widget. This particular thing is not at all useful, but I needed something to put in there as an example. And once I do that, if we look at the JSON schema, here's that extra information. And there are, using SciPy Auto UI, which I'll introduce in a moment, which is the thing that generates the user interface for you. It's via this JSON schema extra that you can do things like override what it chooses for you as a widget. Okay, so speaking of SciPy Auto UI, and this part I still find kind of magical. So SciPy Auto UI is a package that makes a widget for you from a Pydantic model. So to make a user interface, you import Auto UI, and there's your widget. There's some things here that are confusing, and there's some things we don't want, like year range was supposed to be a range of integers, right? But instead we have the show button, and the show button gives you a plus sign, and that's, okay, I don't even know what that means. So we have something not quite right here. There's some other pieces in here that we maybe want or maybe don't want. There's a save and reset bar. The idea of that is that if you want to be able to save the values and give the user the option or an interface for saving the values, it'll generate that for you. And by default, if there are validation errors, it will show that for you here. Most of these components, you can turn off their display if you want to. But what I want to talk about next is this year range thing and why that's happening. So the issue is that right now, when we've described year range, we said it was a tuple of two integers, and that's not really what it is, right? The constraint is that the first integer has to be in the range of years that are in the data, and the second year has to be in the range of years that are in the data. So let's get that loaded up. So I've just read in the data, and I've got the minimum year and maximum year. And what we're going to do next is make up our own type. The next thing that I'm going to show you is that something that was introduced in Python 3.12. There's a typing extensions package that brings new typing features back to previous versions of Python. And one of those things is the type alias type. And what it lets you do is define your own type. The way this looks in Python 3.12 is a little bit different. It's more compact and neater looking, but the idea is we're going to make a type of integer called a constrained int. To use the type alias, I have to repeat the name. It's one of the things that gets fixed in Python 3.12. And now I'm going to indicate that I want it to be an int, but annotated with this extra restriction that the value has to be greater than or equal to minimum year and less than or equal to max year. And so in Python 3.12, it's quite a bit more concise. And now, if we rewrite the model, here's what it looks like. So now the key change is here, where we've said that the year range is a tuple, and the two pieces of the tuple each have to be a constrained int. Okay, so the next exercise is to try out Auto UI and make the user interface for this. Question?
How come you don't need to, for the slider range, the second value can't be less than the first value? Constraint is just
Right.
telling.
So the question was, in our constraint, we've said that the first value has, this range, second value has a range, but there's nothing that restricts one of those, insists that one of those has to be bigger than the other. Let me come back to your question in about 30 seconds once folks have generated the UI.
It's more just a line thing.
So to do this, now we're getting a year range, and the initial value is what we put in as the initial range of years. And so SciPy Auto UI recognizes a constraint like this as indicating you want a range of values, and generates a user or a interface element with the minimum and maximum values of the constraints that you put in. Other questions about this? Okay.
What does the check mark do again?
Okay. Let's see if I can break. Oh yeah, I can break this. So the check mark of the red X is indicating whether or not you have a valid pedantic model. And so right now the problem is that the polynomial order is bigger than the window size, and it's displaying the error. If I increase the window size here, I have a valid pedantic model indicated by the check mark.
Okay, and what about the box that's a red circle now? That is sometimes a check mark.
Okay, so the green button here, if you click on it, and if you've told SciPy Auto UI where you want to save the file, When you click this, would save it to JSON. The check indicates that the value has been saved. It's red if it's not. And if I make another change here, and I had provided the file where you wanted to save this, then the yellow would reset to the last value. Okay, let's go ahead and save the notebook first, and then export with nbdev. And when you do that, there should be a new folder. Yeah, there it is. That was a tense, like 5 seconds there where Jupyter was thinking about it. There should be a folder called dashboard Pydantic, and in that, a Python file called Pydantic model. I'm not going to discuss this at any length, but if you have some classes that you work with that you want to be able to use with Pydantic and you can't go and rewrite those classes as Pydantic models, Pydantic 2 provides a way of adding some of the Pydantic methods to any class. And so it's useful to be aware of, but we're not going to talk about it. Okay, let's move on to Notebook 3B. I wanted I had to have a long discussion about who did section 2 and who did section 3, because I really wanted to say, open up Notebook 2B, or not 2B. Yeah. The only thing that makes programming pain less is by increasing the pun pain.
I was originally going to do Notebook Juan.
Oh, we're on a roll. Okay, so go ahead and open up Notebook 3B. And in this notebook, we're going to talk a little bit more about IPy Auto UI. We're going to come up with a way of dealing with the user interface when there's a bad Pydantic model. So we should have something happen if the user, makes an invalid model. And then we'll implement some of the yeah, I think I've covered it. So start by importing the dashboard. And just as an overview, right, what we just did was define a Pydantic model. We put that model into Auto UI, and we get back a widget. It turns out we'll talk about this in a couple of minutes, that widget has a value. That value is easy to save to disk. You can observe that value. So we've already got a simplification, because instead of having to observe 3 different values, year range, window size, and polynomial order, we're observing one value. That's a dictionary with all 3 of those things. I'm just going to go ahead and load the answer key here. So the idea was to create a Pydantic model that just had a window size and make the UI for that. So let's execute that cell and make the UI, and then display it. Whoops. Okay, so this has chosen a integer text box. So I'm pushing my decimal key and it won't let me. I'm trying to type characters, it won't let me. So even in the simple case, Auto UI recognizes that you wanted something that represents an integer, so it's picking the appropriate widget for you. There's a couple of things that are helpful to know about the widget that gets generated by Auto UI. One is that it gives you a dictionary of the individual widgets. So if, for example, I wanted to directly set the value here, and this is not the way I would do it in real life, but I'll show you real quick. I would get the window size, widget, and set its value to 42. The Auto UI generated widget also has a value, and that value is a dictionary. And so if I actually wanted to do the change I just did of changing the window size, I would do it by doing that. So I'd set the whole dictionary, and if I'm fortunate, yeah, this is reset the value to 11. So You can also observe changes in value. There's a twist here. The name that you want to observe for an auto UI widget is underscore value. I don't entirely understand why it's that instead of value, but that's the way it is. And so if I add an observer and then change the value of the user interface, or in the change the value, then my observer runs and prints out what the new thing is. So the observing works the same way it did before. Again, the simplification we're going to get is that the value is a dictionary, and we only have to watch that value. We don't have to watch the three things individually. As you start to add constraints, so I still just have a window size as an integer, but now it has to be greater than or equal to 2. Auto UI takes that, lets you set invalid values if you want to, still representing it as a text box. And we can verify that by looking at the dictionary of widgets, and the window size widget is an integer text. If you want to, you can override that. And so I mentioned before that the JSON schema extra is one of the ways of providing additional information to auto UI. And it's got it will look for a keyword auto UI, and if you tell it what kind of widget you want, it will use that. So the thing I'd like to fix here is that SciPy widgets has a bounded int text. So if I've got a minimum value of 2, I don't want the user to be able to enter a value less than 2. And so one way I can get that is forcing auto UI to use this particular widget. And when I do that, I can't make the window size less than 2. And we can, if we look at the widget dictionary, now we see that the window size is represented by bounded int text instead of regular int text. Let's take this one step further and add the other constraint that we want the window size to be less than or equal to 100. I've taken the specification of what kind of widget I want out of here. And in this case, since I've given a minimum and a maximum value, SciPy Auto UI guesses that it should use a slider instead of a box. And the description that I've put up here into the field is showing up here in the user interface. Okay, questions? Yep.
Just verifying what I think I heard you say, which is that depending on what you pass into the field, it decides which widget you want.
Yes.
Okay.
And so there's two approaches you could take to this. You could just try different things until you get the widget you want. You can force it to use a particular widget. I'll show you a demo feature that it has in a little bit. And so if I'm not sure what to do, I'll look at their demo, find a control that looks the way I want it to look at the code they used to make that, and then do that. That's how I did the year range slider. So okay, so let's import our data selector model that we made before. Make that model as controls. And I should have displayed that. Get the exercises just to make an invalid value, so I'll just go ahead and do that. So the thing I added here was I displayed controls. I'd like to fix this. In the first version of the widget, one added an observer on window size that when window size changed, it reset the maximum value of polynomial order. So we'll come back and fix that in a moment. In the meantime, there's a couple things I want to get out of the way. We're not going to be using this save button, so I want to get those turned off. And I don't want to display the validation error necessarily. Both of those can be controlled. SciPy Auto UI calls this top element the save button bar. That's called validation. And so if I turn both of those off, the save button bar is gone, and the box explaining what the validation error is gone. The red X is still there. If you wanted to turn those back on, you can do that. So if I turn the validation back on, and then change the value, whoa, how did that not work? Oh, because you have to run the cell twice. The first time gets you the answer, the second time runs the answer. So now we've got the validation error box back. Okay, so there's a bunch of different ways, so I want to talk a little bit about the window size and polynomial order. There's a bunch of different ways that you could address that. It's not like the polynomial order is bad given the window size. You could think about the window size being bad given the polynomial order. And so if there's a conflict, you could imagine doing what we did the first time. So observe window size and adjust polynomial order to be appropriate. You could observe polynomial order and force the minimum window size to go up based on the polynomial order. An alternative is if the user changes the controls to an invalid value, just set it back to the last valid value and display the error message to the user, and they decide whether they should increase or decrease the polynomial order or increase the window size. And I'm going to do that last thing here just to demonstrate a different way of handling it than we did the first time around. So, a couple things. We're going to grab validation error. And I've got a function which is going to build an observer for me. How many of you have used closures? Okay, one or two. So the closure is essentially a function that returns a function. And the way I'm going to use that here is that, or the reason I'm using that here, is I have a user interface element that I want to attach an observer to. The observer itself, as its argument, has to take a change. That's the way SciPy Widgets works. I can't change that. I have no pride, sorry. And so the way I approach this is that you call make enforcer with an auto UI thing. What it's going to do is try to make a pydantic model from the values. So when we're using this, the constraint enforcer function will get called. Its argument will be the change. The change will be whatever the new widget values are that you've put in. The way I can see whether or not those are valid is I can ask the UI to tell me what pydantic model it used, and then initialize that pydantic model from the change. If that succeeds, I don't need to do anything. The user passed in good values. If that fails, then I just changed the value back to the old settings. So that's what the observer itself is doing, and then the make enforcer function returns that observer. And so the way this looks, I should execute that in practice, is that like we did earlier, I've got a widget controls. I wanted to observe something. The thing I wanted to observe is the value, and the function I wanted to call is this. So this is a function call, but the function call is returning constraint enforcer, and constraint enforcer is a function. The reason for the indirection here is that inside of the observer, I need to know which user interface piece I'm working with, but I can't pass that into the observer itself. So instead, I pass this into the outer make enforcer function. I can use that value inside here however I want, and Python somehow magically keeps track of all of that for me. So let's run that. And now let's see what happens if we find our widget. I've heard there's this thing called create new view for output that I should have used. And now if I, well, I'm curious to see how this is going to work. So make sure nothing terrible happened. Yeah, okay, got a validation error, I knew that. Okay, let me turn this up to 10. Oh, geez, I really should have made that 11, but. And then as I bring this down, I've gotten a validation error telling me that the polynomial order must be smaller than the window size, and the slider values have been reset to 11 and 10. So if I try dragging this down, you can see no matter what I do, it's putting it back to the last valid value. Questions about that? Okay, so make sure you run the last cell here with the nbdev export, and when you do, if you look in dashboard Pydantic, you should now have a widget's auto UI. Yeah. All right, let's open the next notebook is 3C, the other dashboard elements. Right, so this is great. We've been back for 40 minutes, and we have recreated 3 sliders. But I seem to recall there were other elements to this dashboard, so let's do that. And so here, the thing I'm going to change up a little bit is taking what we had as separate widget components in the first version of this and combining those into classes to make it a little bit easier to manipulate them. So I'm going to need SciPy widgets. And in this cell, this is the same text we had before. I've just copy-pasted it. And I'm going to make a text boxes object. I'm going to subclass that from widgets vbox. The piece of doing this that I always forget is that when you're making a subclass, you need to call the parent classes init. That's the way to do that. I'm going to handle the layout inside of this. So we wanted a max width of 500 pixels, and we wanted a particular set of margins around the text. And now I'm going to make my 2 HTML widgets inside the class and make the smoothing attribute one of those, the sources attribute the other. I'm going to use the layout I defined. So this layout is for the VBox, because self here is a VBox. And then I'll set I'll set my children to these 2 widgets. And so when I do that, I get these 2. Now for the plotting and stuff. So what we're going to do, the new thing in this next class is going to be that in addition to putting the plotting widget and the table display widget into a class, we're going to make our own traitlet, our own thing that we can watch and observe. And a couple ways you can do that in the widgets framework, but one is to, well, a couple ways you can observe that. What we're going to use here is that I'll have a method inside this class that gets called anytime the smoothing information changes. So the idea is that eventually smoothing information will be a dictionary that contains the year range, the polynomial order, and the window size. And when that changes, I want my plot to change, and I want my data display to change. So in this case, instead of subclassing from a widget, I'm subclassing from traitlets.hasTraits. Under the hood, VBox subclasses, I think, from box, and box subclasses eventually from hasTraits. So under the hood, this was happening, happens in widgets already. And this is where I define the smoothing info. I want it to be a dictionary. It's okay if it's none. The default value is none, and the tag sync equals true. Make sure that if you're working on the JavaScript side also, that JavaScript will know about changes to the smoothing info. I will admit that the very fun Any Widgets tutorial this morning changed my mind a little bit about JavaScript, but generally I really try not to think about JavaScript or use JavaScript. I like to go as far as I can with Python. But if you do use JavaScript, that last bit is important. And I thought it'd be convenient to have the data in here as an attribute. We've got an output widget that we'll put the plot into, and the data grid that we'll use to display the data. And then all of the action here is packed into this. So, whoops. So the observed decorator says that when there's a change to the traitlet smoothing info, you want the thing you're decorating to be called. That thing will be called with the argument change. Since this is a method of a class, self has to be the first argument, but the other argument will be change. Inside of here, the first thing I do is take those things out of the dictionary that they're going to come in as. It's going to be a dictionary because our controls made with SciPy Auto UI, its value is a dictionary. So that's what I'm eventually going to link up to this. Once I have those, I add the smooth column to the data. I make a selected attribute that is the what we called selected df before, so I'm getting the range of years that I want. And then when I was writing this, it was starting to get a little bit long, so I made a separate method for displaying the plot and another method for displaying the data. And display plot is literally the same text as before, or sequence of commands as before, but I changed selected df to self.selected. And display data is kind of fun. All I have to do to update the data grid is update its data. So let's make one of these and see if it actually does anything. Oh, I talked about the cell. I didn't run the cell. So nothing happens until smoothing info changes. So let's change smoothing info. And when I do that, I get the plot. Oh, right. Yeah, so I'm only showing the plot output here. I'm not showing the table. Questions? Okay, so one kind of counterintuitive thing here is you might think, suppose I wanted to change the window size to 2. I know that the smoothing info is a dictionary. It's got a window size, so let me change that to 2. Nothing changed up here. The reason is that what Traitlets is looking for is getting a different dictionary. So when the smoothing info changes from one dictionary to a different dictionary, it's like, oh, there was a change. As far as Python is concerned, if you change the value of a key in a dictionary, you haven't made a different dictionary, you've just changed a value that was in there, or you can add keys, whatever. You're not changing the dictionary object itself. So a workaround for that is if I make a copy of the dictionary, I change the value I want in the copy, and then I set the smoothing info to that copy. That's updated the smoothing, is a simpler curve here. I mention that mostly because if you use this, you will forget about this. You will pound the keyboard, and then hopefully you'll remember. Let's make sure that the data display looks good too. So here's the data display, looks like the data grid thing we're expecting. And finally, let's save that. And when you do, you should have in dashboard Pydantic a widgets classes file. So questions and/or issues you're running into? Wow, I'm jealous. None of you have issues. I've got so many. Okay, so let's move on to, well, actually, parenthetical comment, right? So imagine I wanted to do some testing of this. I could test this whole plotting thing without needing to use the rest of the widget mechanism, right? I could try out display plot and make sure it does what I want it to do. Taking this approach helps you decouple moving levers in a user interface from testing the logic of the application you're working on. Okay, so next up, let's open 3D dashboard. And here we're going to put together the final dashboard. So we'll final dashboard from dashboard Pydantic, but we're going to import regular dashboard for the answer. Magic. We're going to import the controls and the 2 new widgets that we made. And I'm going to make, I'm thinking in my head of our original widgets as a vertical box on the left, a vertical box on the right, and those were inside of a horizontal box. And so I'm going to make that structure. On the left are going to be the description and controls, and a VBox on the right will be the data, graph, and table as a VBox, and then the whole thing will be a horizontal box with those 2 as children. So when I run this, nothing's there yet because we haven't put anything into those boxes yet. Right, so to do the data side of things, I'm going to make my, oh, I guess I'm doing both here. I'm going to make one of my data and plot objects, make my text boxes. We had the data in the data table inside an accordion. So I'll make a accordion whose child is the data output with a comma at the end. And I'm going to give it the title selected data. Description and control box is the thing on the left that has the text and the controls. Its children are the text boxes and the controls. And then the data box has my accordion and the plot. So if I do those things and I scroll back up, now I've got a selected data thing I can open and close. I've got my control sliders here. Unfortunately, I don't have a plot yet. And let me, oh wait. Let's scroll all the way down here. Okay, so we're at 2023. Unfortunately, this slider doesn't do anything to that widget. So all of the observe code that we had before is getting replaced by that. So another way to connect widgets is to link them. And what I want to do is link the controls and that value dictionary to the smoothing info of the data and plot widget. To sort of break this into pieces, I've just defined a couple variables here. So the source is I want the value from controls. The target, the thing I want to set based on that, although it does work both directions, is the smoothing info trait of data and plot. And then I say I want those 2 to be linked. And once they're linked, changing one changes the other. And there's the formatting we did in the other one, so I've redone that formatting. Hopefully this looks a little better. Yeah, there can be issues with SciPy Auto UI and some line wrapping with some of its descriptions. I do have a fix for that. That's similar to one that we did before that just shrinks the size of the controls a little bit. Still wrapping because I have I'm zoomed in pretty far. Okay, so go ahead and save that. And I'm going to skip the editorializing about Pydantic. Well, maybe I won't. I'll just do a little bit. So what I encourage you to do is tomorrow, open up the dashboard folder, look at the widget code, open up the dashboard Pydantic folder, look at the code, and see which one's easier for you to follow tomorrow. I find it easier if I've got things bundled up into chunks and I can look at it in an individual chunk, and it's easier if there's not a bunch of changes or observers all over the place that I have to try to link up. We're not going to go, so I just opened up Notebook 3E. We're not going to go through this in a ton of detail. What I want to do is provide you with a example, another motivation for using this approach. So suppose you wanted to make the smoothing optional. So the user has a way of turning smoothing on and off. You could imagine doing that in the first approach, right? So we'd have to add a new control that's an on-off button. We'd have to make sure we were observing that. And you know, I haven't tried that. I don't know how many additional observers we'd end up with, but it'd get pretty convoluted. So the way I'm going to approach, I guess I am going to talk about this a little bit. The way I'm going to approach making the smoothing optional is to break some of the smoothing settings into their own class. So now I'm making a smoothing setting class that has a window size and a polynomial order. All of that is, I just copied pasted from the earlier controls class that we just talked about. And so if I make that widget, I get the same thing I had before. And then my overall controls is going to be a new Pydantic class. The year range is the exact same year range we had before. And now I'm going to have a smoothing property, which is can be either the smoothing setting controls here, so that set of widgets, or it can be none. Let's run that, and when I feed that into SciPy Auto UI, I'm a little confused. So, because I see the year range, but I don't see the other stuff. This can all be manipulated programmatically, but by default, SciPy Auto UI hides any fields that are none. If you click the plus, you see the smoothing settings. It's a nested model, and so you have to click show to get that. And once you've done that, this toggle controls whether smoothing is turned on or not. So right, I had to rearrange, like, copy and paste 4 or 5 lines of code. I didn't have to redo any observers, any of that stuff. You know, the initial display that I didn't like, I can fix using SciPy Auto UI by setting a couple properties. It's not too hard. If I'm going to completely redo this, I want to make enforce the window size and polynomial order constraints. So I use that make enforcer that we had before. I do have to make some changes to the data and plot class. So I added a new attribute to keep track of whether smoothing is on or not. And one of the changes I'm looking for now is whether the smoothing has changed. And I only calculate the smoothing columns if smoothing's turned on. And I only plot the smoothing line if smoothing is turned on. So big picture here, it's just these few lines that I've indicated with the pointy fingers that I had to modify. And then the rest of this I copied and pasted from the previous notebook. Oh, there it is. Wow, I was like, okay, this is really awkward. I don't have a graph. Now I have a graph. Right, so if I turn the smoothing on and off, it turns on and off. And it took maybe, when I was first writing this, 20 or 30 minutes to rearrange the code a little bit to make this happen, but it's much more straightforward than it would have been if I tried to rearrange everything. SciPy Auto UI is a fairly young package, and so it doesn't have extensive documentation, but it has a demo function built in. And the nice thing about the demo function is that it's got a bunch of different kinds of things you can look at, and it gives you several things. So it shows you, say, a list of controls like this. If you click on the pedantic model tab, it shows you the code you would need to write to make those controls. The JSON schema tab shows you the JSON schema that is generating from that model, and you can look at the value of the widget too. So if I'm trying to get, so hypothetically, imagine you're working on a tutorial where you need a year range slider which has, 2 handles on it. The thing you do is you look at this and you're like, oh, look at this, there's an int range slider. How did they do that? And then you look and see how they did the int range slider and do that. Questions? Okay, so we've got 30 minutes. There's one more implementation of the dashboard that we're going to do. If you want to take a second to stretch or stand up or whatever, go ahead and do that, because I don't know about you, but I'm a little at the end of my rope. So, but we're going to start up again in like a minute, so don't go far. And when we do start up, you're going to start on notebook 4C.
There's nothing we can do about it. So skip over it.
SciPy data grid was not happy with Navarro, or vice versa.
It was improperly installed because I'm not too sure why.
Well, I heard that they did some update this morning. They pushed through some update that mocked things up.
Well, no, that was separate Nabari issue.
Oh.
But it looks like pinning data grid to an earlier version works.
Okay.
To an earlier version.
Yes.
So that's consistent with the behavior that I have. So I maintain a library called this not that for interactive labeling of scatter plots. And we rely on the panel and Loki library for doing that, and they have the same kind of issues of augmenting notebooks with JavaScript magic, and there's versions for which that does not work on Jupyter Hub deployments. And when one does Jupyter Hub deployments, you have to make very sure that bespoke kernels have the exact same package version. So yeah, it's a huge pain in the butt scheme. And we got bit by it.
Yeah. Okay, so once again, open up the notebook that's called 4C Solera. Can somebody do me a favor and ask me if I anticipate there being any problems? Somebody. None that I foresee. I'm sorry, I wasted probably hundreds of dollars of people's time there by actually taking the time to make that joke. If you'd like a refund on that portion of the tutorial, talk to me afterwards. I've got more puns. So what we're going to talk about now is something called Celera. This is the portion of the tutorial that Martin Breddels worked on, and he's the one who wrote the Celera package. It builds on SciPy widgets, and so it's not completely separate from SciPy widgets, but it provides a very different way of thinking about putting widgets together. So we're going to start out with a whole bunch of imports. The only new one is Celera up here. And I'm going to go ahead and get the data read in so that in the rest of the notebook we can use that. So the interesting thing about Celera is instead of declaring explicit observers, you indicate that there are some variables that are reactive. And what reactive means is that if there's a change in that variable, in some component of the dashboard that you're working on, then that component will automatically get called, sort of like an observer, if the value that you want to react to is changing. Some of the language here comes from the React JavaScript framework. I'm not actually familiar with that framework, but that's where it comes from. And so I'm going to start by working on the controls. So we had a year range, a window size, and a polynomial. To declare those as reactive, you use Celera reactive, and then you provide the initial value for the variable. And that initial value can be anything. So in a little bit, well, one of our reactive variables, its initial value is going to be a data frame, so that if the data frame changes, we can observe that. And so let's run this and then print one of the values. It's just a tuple. So the way that Celera builds widgets is using what it calls components. And so what I'm about to scroll here is a replacement for those three year range, window size, and polynomial order items. So if something's a component, I indicate that by decorating it with Celera.component, and then define a function. And these three controls I wanted to be vertical, and so I do that layout by using this Celera column as a context manager. So anything within that block is going to show up as a as one element in the column. And we had three things that we wanted. The year range slider is declared here, so this looks fairly similar to the int range slider declaration from SciPy widgets. And then the other two are integer sliders, and I'm setting the maximum and minimum values. And then at the end of this, I'm returning the control that I've constructed. Now, the magical thing is going to be that because year range is a reactive variable, any changes to that are going to cause this to be updated. So if I set the value of year range, Celera will know that it should update the year range slider. This also gives you a way of limiting the polynomial order. So the thing we did to limit the polynomial order was in the first case was to reset the maximum polynomial order to one less than the window size. That was an observer that we wanted to have called anytime the polynomial order changed or the window size changed. So to make that happen here, I say it's a Celera component, and then inside the function I just use polynomial order. I promise no more puns. I wasn't crossing my, okay, we're back. Let's see, so behind the scenes, Celera works some magic so that if polynomial order changes, its value changes, or window size changes, this gets called. So the next component I'm going to do here is make the data frame, the selected data frame, a Solera reactive variable. So I'm using as the original, or as the initial value, a copy of the original data frame. And so now anytime the selected data frame is changed, Solera will communicate that change everywhere it needs to be communicated. So the next component I'm going to define does two things. It calculates a smooth column, and it updates the value of this selected data frame. So I should step back half a second. So as a reminder, when you declare a reactive variable, the way that you get the value of that variable is with dot value. So it's behaving kind of like a widget that way. So inside of this function, it's the same code we used before to calculate the filter, the smooth column. This is the same sort of pandas data frame selection we used. Because it's a Solera component, any the change we make here to the data frame will trigger updates everywhere they need to be updated. If the window size or polynomial order or year range changes, this automatically gets called. So one of the things Solera does for you is it removes having to set up all of the observers that notify each other when something has happened. Okay, so now what do we need to do? We need to make a plot. So I'm going to do that as a Solera component also. And I just plot the data here because this is a Solera component, and because I'm using the selected df, which is a reactive variable, when the selective data frame changes, the plot function gets called. And the last bit of this is that to define the overall dashboard, in Solera, if you define something called page, that's what gets rendered by default if you deploy a Solera app. So I'm going to make that a Solera component. The first things that I'm doing inside of that is calling our component that checks the polynomial order with the window size and the one that does the data selection. Solera tries to be clever, and if it sees a component that you don't actually render on the screen, it won't ever call that component. So to make sure that these two actually get called, they have to be inside of a component that's displayed on the page. So calling them here does that. Let's see. So we're not going to do the text part of the widget here. Remember, the layout was that we had one column with text and then controls. The other one was the data table view and the plot. So I'm thinking about that as a row. And in that row, there's one column that has text and our slider controls. And then the other column has two things. One is the plot itself, so it's the plotting commands we used before. And the other is sort of like an accordion. The details component displays this text, whoops, and a little triangle. You click the triangle and it shows you the content. And the child of that, I've made the iPad data grid view of the data frame. And so there's the dashboard. And oh, right, I can't, yeah, right, see, I can't increase the polynomial order because I didn't increase the window size. So the look of the widgets is different. By default, this is using a package called SciPy Beautify to render the widgets. I can show the data here. And I didn't actually think about this when we were talking about the organization of the tutorial, but right, it took us 2 hours before the break to get the first version out where we were manually doing everything. It took about 45 minutes, I think, to go through the Pedantic version. It's been 15 minutes since we started this. And I know I've kind of rushed through it a little bit, but this was my first experience with Solara, and it's pretty nice. I mean, for this other application Juan and I are working on, we need to be able to save settings for disk and that kind of stuff. So sticking with SciPy Auto UI is the right call for that, I think. But it's starting to think of this as like the golden age of widgets. Back in the old days, you had to build everything from scratch, and now you've got SciPy Auto UI, you have Solara. There's a couple other things that in our Notebook 5 we provide links to. I went to the AnyWidget tutorial this morning. It made JavaScript seem fun. Yeah, we don't have time. Okay, so questions. Yep.
With SciPy Auto UI, we can hook up to our regular just plain SciPy widget stuff with links and things. Can you do the same thing with Solara, or is that an example?
So the question was, can you link regular widgets into Solara or not? Okay, but the answer is yes. And I thought I had it in here as an exercise, but apparently I don't. Yeah, so you could stick a regular widget in here. Let's see if I can just, do we have, let me make sure we've got SciPy widgets imported. Ooh, wow, I feel a little bit guilty. I didn't even import it. Okay, let me add it down here. Okay, let's see what happens. That's disappointing.
Don't you have to redeploy? Don't you have to re-execute the cell that is?
Yeah, I thought I just did.
No, the H display.
Oh my gosh. Yeah, it's still missing. Okay, so the answer is yes, but apparently I don't know how to do it on the fly. But yes, you can. So it's not something that's separate from SciPy widgets. It really is built on SciPy widgets, and you can use them together. Yes?
More like a general question. I've seen that Martin released a website where you can kind of run the Solara. It seems like it's like everything happening in the front end, basically. Like, can all of this run server?
So we're not going to talk through these in detail, but because we're running out of time. But where do I have the link to that? There it is. So there's a service called PyCafe.
Yeah, exactly.
Yep. And so let's give it a second to load here. So I've got the step-by-step instructions of how I set this up in that notebook. But essentially, I had to upload our Solara implementation of the widget. I had to upload the data, and I had to upload the requirements. And the special thing about this that you alluded to is that this is running using Pyodide. So it's a basically Python package is a JavaScript package. So this is not running on a remote server. This is running in my browser. So this scales well because, you know, as you get new users, you're serving up a relatively small bit of data for them, and it's their computer that's doing all the manipulation of the data. I believe that PyCafe itself is running in Pyodide because as you make changes here, There's let me make a change. So I just typed in some new text, saved it, it's re-rendered it. See the little red dot there? That means I've modified something, and that modified thing hasn't actually been saved to my account on PyCafe until you push the cloud. I reloaded yesterday, and it all went away. Because it was all running in my browser, and so I hadn't pushed the cloud anyway. So this is really promising. There's something. Let me give you a quick rundown of the things we didn't talk about. Yeah, we're at about 10 minutes left. So in Notebook 4a, there's a description of how to deploy dashboards that talks through sort of the server-side version of this, where you have a Python kernel running on a server somewhere and the user is connecting to that. And there's a few different ways you can set that up. We do have instructions here for setting it up in Binder. Oh, there's an outline thing. And for setting up a Docker file with a dashboard in it, and how to then go ahead and deploy that. And I apologize, Nicole doesn't get to discuss that because we're running out of time. Wanted put together a description of using something called Voici to, go ahead. Voici. So he's been practicing the pronunciation for days. What's ironic is he trusts that I'm pronouncing it correctly. What Voici does is tries to build for you a Pyodide-based version of the dashboard that you can distribute from a static site. So we didn't get it working entirely. Yeah, come on up.
So if you take that first dashboard that we built and try to run Voici on it, the failures appears to be that the matplotlib component doesn't update. So the sliders work, the data updates. Now matplotlib, for those of you who don't know, behind the scenes it's not widget based. So there's an issue there that I suspect is related something to that. I have run much more complex widget-based stuff. I have a binary star simulator that I have written with a lot of controls. It renders 3D stars orbiting each other. Works perfectly in Voici. So Voici is, as long as you avoid matplotlib, may be a very good option for a lot of stuff. It seems to work quite well. But I just wanted to make it clear that even though we ran into this one problem deploying this one dashboard, I've now tried it on a whole bunch of other dashboards, and I have yet. Anytime I've run into a bug, it's a bug that I caused, not Voici.
And it's a static site.
It's static. Oh, that's the beauty of it is.
Repeat the question.
Yeah, I was asked if it was a static site. Yeah, the beauty of Voici is, as opposed to Voila, I deployed it for a class. As soon as you have 10 people running the same dashboard, it bogs down because it's all running on the server. The beautiful thing with Voici is it basically passes everything to the user and says, hey, you're on your own for doing this. And so it's all running in their browser as opposed to on your server. So yeah, it's a nice option because a very small server can manage it as opposed to you needing to have a server with a ton of memory just in case you have simultaneous users of Voila.
So at this point, let's just open it up for whatever additional questions you have. Yep. Go ahead. What about testing? So let me switch back to this for a second. So the nice thing about this order division where we have most of the logic is in pedantic and auto UI is generating the UI is I can write tests that call the pedantic classes, and if they work, I know it's working, right? So I don't have to use, there's a package called Playwright that lets you try out JavaScript stuff in a testing environment. I've never understood it or gotten it to work, but we've got hundreds of lines of tests for this code, but it's just calling the pedantic models. One thing to be aware of is that if you do want to test some of the user elements, you can set values of widgets programmatically, and it's the same as if you'd set them in the user interface. Buttons have a click method that you can call that simulates a user click. So you can do some user interface testing too without having to resort to Playwright. Yep, in the back there was a question back there, and then over here. Yeah.
Yeah, so I've run cases where like you have a dashboard and scientists or the PI says like it'll be cool if you can like share the state of the widget with collaborators and just like in JavaScript you have a URL that basically has some parameters and stuff.
Mm-hmm.
Is there a mechanism where like you can share a state, the current state of a widget and all of this?
So the question was whether there's a mechanism for sharing the current state of a widget and all of this, or sharing a visualization. So one way to approach that, if you're using the pedantic approach, is you save a JSON that's got all of the values in it. You read that back in. If you're packaging up, packaging things up in Voici, I'm not entirely sure how you would do that, but yeah, but partial answer anyway. Juan or Nicole, if you have anything to add. What? Oh, yeah, you can pickle your model and send that. And there's a question in the back. Yep.
Is there a way with the iPod or the UI to change the layout, or is it all?
So the question was whether there's a way with SciPy Auto UI to change the layout. Yes, but you have to dig a little bit. So it's setting at least a maximum, maybe a minimum size on each of the controls. But once you know where to look for that, you can change it, right? The individual controls are just widgets, and so you can change their width if you want to. The way I think about it is the trade-off I'm making is that I don't get to make it look exactly the way I want it to look, but I didn't have to think about how it looked. So sort of, remember at the beginning I was handing out Post-its? It was amazing how many people freeze up when you say choose a color. Because they're like, oh, I don't know what the right answer is. And I think of designing UIs as kind of the same way. In the end, it doesn't matter exactly how it looks, but it matters that there's a UI. Yeah, but that's sort of the current state of affairs. Go ahead. To build a what? Oh, to build a is there a way to build a multi-page app with this? Nicole, you were nodding your head yes.
Yeah,
Wait, can you come up to the mic?
I would just say that to build a multi-page app, the way around that is to have a tab-based application. So you use a tab widget, which is a container widget. And so that basically, you can click through the tabs, but generally I have a next button at the bottom that I hook up that, you click on the next button and it moves the tab for you. So that's the workaround.
One additional response to the question about whether you can customize the styling. So in this, I'd never wanted the pedantic errors to display. There were a couple of, I always wanted, where is an example of this? This is a nested model, but I always wanted it to be showing the nested model. I never wanted SciPy Auto UI to hide the null fields. I wanted people to be able to see those. So what I did, I'm not going to be able to open it. Basically, I wrote a function. I pass in a pedantic model. It makes the UI. It customizes the setting I want and gives me that UI back. So I only had to handle the formatting once. Time for one more question. Okay, then thank you, everybody, and it's time for the reception.